ஹலோ வைஷ்ணவி மேடம்.
சார் ஸ்கிரீன் ஷேர் பண்ணலாமா?
பண்ணிக்கலாம் மேடம். அதுக்கு தான் நான் முன்னாடியே வந்தேன் நானு. ஒரு 2 மினிட்ஸ்.
நீங்க டிசேபிள் பண்ணோம் சார்.
எனேபிள் பண்ணுங்க. ஒரே நிமிஷம் மேடம். இப்போ ஓகேன்னு பாருங்க மேடம்.
தெரியுதா சார்?
ஜஸ்ட் a minute மேடம். ஓகேங்க மேடம். So again நீங்க எனக்கு திருப்பி ஹோஸ்டா மாத்திருங்க so that I can allow the participants into the meeting.
Okay.
அதுக்கு நம்மளே ஹோஸ்டா மாத்தணும். மேடம்? Yes ma'am. Yes ma'am. It's done okay.
Sure.
So another 10 to 15 minutes நம்ம ஸ்டார்ட் பண்ணிடலாம் மேடம். 9:40 ஆச்சுங்க. பிரின்சிபல் சார் ஒரு 10 மினிட்ஸ்ல வந்துருவாருங்க. இந்த 10 மினிட்ஸ்ல ப்ரோக்ராம் பத்தின டீடைல்ஸ், செஷன் டீடைல்ஸ் எல்லாமே சொல்லிடலாங்க. நான் பார்ட்டிசிபென்ட் சொல்ல அலோவ் பண்ணிடுறேன். அலோவ் பண்ணிட்டு டீடைல்ஸ் எல்லாமே சொல்லினா ஒன்ஸ் பிரின்சிபல் சார் வந்ததுக்கு அப்புறம் வெல்கம் அட்ரஸ் முடிச்சிட்டு செஷன் நீங்க ஹேண்ட் ஓவர் பண்ணிடுறேன் உங்க கையில. நீங்க அதுக்கு டேக் ஓவர் பண்ணிக்கங்க.
ஓகே சார்.
ஓகே மேடம்.
இந்த ஸ்கிரீனை ஸ்டாப் பண்ணிடவா? ஷேர் பண்ண.
நோ இஷ்யூஸ் இருந்துட்டு போகுது. ஒண்ணும் பிரச்சனை இல்ல. நீங்க திருப்பி ஸ்டாப் பண்ணிட்டீங்க அப்படினா நான் திருப்பி உங்களை ஹோஸ்டா மாத்தினா தான் பண்ண முடியும்.
ஓகே.
அதனால ஸ்டாப் ஷேரிங் கொடுக்க வேணாங்க. அது இருந்துட்டு போகுது. ஒண்ணும் பிரச்சனை இல்ல. நான் பார்ட்டிசிபென்ட்ஸ் உள்ள அலோவ் பண்ணிடுறேங்க. Thank you.
ஓகே.
Good morning, everyone. On behalf of Velal College of Engineering and Technology, we would like to welcome our principal, Dr. M. Jayaraman Sir, Dean Academics, Professor L. Peter Stanley Bebbington Sir, Dean Student Affairs, Professor P. Jayachandar Sir, Controller of Examinations, Dr. K. R. Vallavan Sir, Administrative Manager, Periyasamy Sir, heads of various departments, and all the faculty members for the AICT sponsored online short-term training program Series 1 on deep learning applications and challenges in big data analytics. A quick glance at this program. This 6-day AICT sponsored online short-term training program, Series 1 on deep learning applications and challenges in big data analytics starts today, that is from 7th August to and ends on 22nd August. The first session starts from 9:30 a.m. and to 11:30 a.m. The second session starts from 11:30 a.m. to 1 p.m. and the third session begins from 1:30 and ends at 2:30 p.m. and the last session starts from 3 to 4 p.m. In between, you will be having tea break for 30 minutes and lunch break for 1 hour. At the end of the session, that is on the final day, you will be having an online test for certification. This will be followed by valedictory function. About today's STTP program. Deep learning, known as deep structured learning, is a subset of machine learning, where machines employ artificial neural networks to process information. It's a new way of doing deep learning, a change in the entire system, inspired by biological nodes in the human body. Deep learning helps computers to quickly recognize and process images and speech. Computers then learn what these images or sounds represent and build an enormous database of stored knowledge for future tasks. It has networks capable of learning unsupervised from data that is unstructured or unlabeled, also known as deep neural learning or deep neural network. The artificial neural networks are built like the human brain with neural nodes connected together like a web, while traditional programs build analysis with data in a linear way. The hierarchical function of deep learning systems enables machines to process data with a nonlinear approach. Deep learning is used across all industries for a number of different tasks. Commercial apps that use image recognition, open source platforms with consumer recommendation apps, and medical research tools that explore the possibility of reusing drugs for new ailments are a few of the examples of deep learning incorporation. It's a busy day in 2039, and you are watching a movie with being shuttled around by one of the countless autonomous vehicles that prowl the world's roadways. It brakes and accelerates when necessary, avoids smashing into things, obeys all traffic signals, and always stays within the lane markers. Topics to be covered in this STTP program: Introduction to Big Data, Machine Learning and Deep Learning, Route to Big Data Analytics, Overview of Machine Learning, Evolution of Deep Learning Algorithms, Recurrent Neural Networks, Deep Neural Networks Model, Overview of Hadoop Architecture, Big Data Tools, Deep Learning Platform and Libraries Python, Convolutional Neural Networks Model, NoSQL Case Study, Usage of Big Data in Deep Learning Algorithms, Hands-on Training on Spark, Hive, Pig, NoSQL Database, Scope of Research.
Good morning.
Now we would like to welcome our beloved principal sir, Dr. M. Jairaman, for the 6-day AICT sponsored online short-term training program on deep learning applications and challenges in big data analytics. Now I welcome Dr. M. Jairaman sir to proceed with the inaugural function.
Shall I start? Hello.
Sir, you may start, sir.
Good morning, ladies and gentlemen. Most respected chief guest and the keynote speaker of the morning session, Professor Vaishnavi Murthy, Faculty of Computer Science Engineering, SRM Institute of Science and Technology, Chennai. Respected Head of the Department, Dr. V.K. Manavala Sundaram, the convener also. Respected professors, heads of the departments, and coordinators, Dr. Ganesh Kumar, Professor V. Gomati of IT department, and the participants from our own institution and other institutions, and Colonel Venkat, Director, Faculty Development Cell, AICT, and my dear students, good morning to everyone present here. It's a pleasure to associate myself with this online STTP organized by the Department of IT, which is sponsored by the AICT, on Introduction to Big Data Machine, that is deep learning applications and challenges in big data analytics. First of all, I congratulate the head of the department, Dr. V.K. Manavala Sundaram, and coordinators, Dr. Ganesh Kumar and V. Gomati, for their effort to organize such a nice topic for the online STTP. And as you are all aware of that, we have been attending and organizing various online programs, webinars, workshop, STTP, training, then lot of things for the past 5 months. So in our institution, if you put together, if you see the certificates, online certificates and other things, it crossed about 1,000 for the past 5 months. So many programs attended by the professors. But only thing is whether we are carrying forward to the classroom atmosphere. That is the major thing. So whatever you may learn in the faculty development program or short-term training program, but you have to take forward to the students community. So then only the outcome will be completed. So it is very difficult to train all the faculty members in the latest technology or latest topics. So that is why AICT is organizing so many short-term training programs and training only a 10% or 20% in this area. So you have to learn a lot and you have to proliferate this to your colleagues, and also you take forward to the student communities, either offline or online classroom. So especially because of the invent of the internet and other things, the big data is a talking point for the past decade. But now only we could observe, and we are seeing the actual potential. So many data transferred daily. Recent past, if you see that, Troy is astonished with the data transmission for the past 5 months. We are unable to cope with those things because already we have foreseen and we have developed our own infrastructure, but still there are a lot of problems. So you cannot send all the videos and the audio files and other things because of the network congestion. Still, many of the places in India, they are unable to reach the network. So this is the condition. So the big data plays a vital role. Already many of the top companies implemented a lot of things. Especially, we are thinking that artificial intelligence is a new word. It is not a new word. It was coined in the 1952 itself, because artificial intelligence, especially implemented in the manufacturing sectors, especially in the robots. Since I am belonging to mechanical engineering, so artificial intelligence initially developed for giving the knowledge, and the routine work can be avoided by the machine interface. So they formed a lot of things. But now, due to the advent of latest technologies, the big data plays a vital role. Definitely, the artificial intelligence, machine learning, deep learning, all are very much important. And we used to talk only the artificial intelligence and machine learning, but now we are talking about the deep learning, because how long we can give the information, how long we can program the machines or whatever may be. So it should be done automatically. So from the available repository, knowledge what we train, it has to evolve itself, the machine itself. So that is called the deep learning algorithms. Already we are having a lot of things happening in and around the world. But this STTP will throw some more insights, because so many experts are going to deliver the lectures. So I request all the participants listen and learn more and transfer the knowledge to the younger generation. Definitely it will be useful. I wish the STTP a grand success. Thank you.
Thank you for your valuable words, sir. Yesterday is gone, tomorrow has not yet come. We have only today. Yesterday is gone, tomorrow has not yet come. Yesterday is gone, tomorrow has not yet come. We have only today. Let us begin. On behalf of IT department, I extend a warm welcome to Ms. Vaishnavi Murthy ma'am and to all the participants. It's an honor to introduce Ms. Vaishnavi Murthy ma'am. She is an assistant professor of CSE Department of SRM Institute of Science and Technology with an academic experience of 7 years. She received her BTech in Computer Science and Engineering from Bardia University and MTech degree in Computer Science and Engineering from Bardia University. She is doing her research in mobile cloud security in SRM University. She has published 6 Scopus indexed articles in both national and international journals. Her areas of expertise are software-defined networking, network security, cloud security, geographical information systems, Internet of Things. She was certified as Microsoft Innovative Educator. We are grateful to her for accepting our invitation to share her knowledge on deep learning. Now I request Ms. Vaishnavi Murthy ma'am to start the session. Thank you.
Sir, good morning. On behalf of Department of Information Technology of Vellalar College of Engineering and Technology, I am Dr. V.K. Manavala Sundaram, Professor and Head, present here to welcome our management and principal to provide me and this opportunity to apply for this 6 days AICTE STTP program. And I thank our AICTE to sanction the grant in aid of rupees 3,20,000 for conducting this STTP. I welcome our secretary and correspondent Thiru S.T. Chandrasekhar sir, our beloved principal Dr. M. Jayaraman sir, our Dean Academics Professor L. Peter Stanley Bivington sir, our Dean Student Affairs Professor P. Jayachandran sir, and our Controller of Examinations Dr. K.R. Valluvan sir, all the heads of the various departments, faculty members and staff members for conducting this 6 days STTP program on deep learning applications and challenges in big data analytics series 1. We are going to conduct 3 series. This is series 1, which will be conducted from today onwards to 22 August 2020. So in this program, we will like to cover various topics like big data, introduction to big data, machine learning and deep learning, route to big data analysis and overview of machine learning, recurrent neural networks, deep neural networks, overview of Hadoop architecture, big data tools, deep learning platform and libraries in Python, convolutional neural networks, NoSQL, a case study, how we can be able to implement this neural networks using our NoSQL, usage of big data in deep learning algorithms, hands-on training on Spark, Hive, Pick, NoSQL database, scope of research in deep learning, scope of big data, HDFS and MapReduce, applications of deep learning in big data, Julia interface, real-time applications of deep learning, a case study and hands-on training. So in this, after covering all these topics in 6 days, we will like to assure you that you will be having the certain languages with hands-on experience in 5 to 10 modules of big data in deep learning technologies. So I request all the participants to be present for the entire session from day 1 to day 6. As per the norms of AICTE, we would like to have quiz program and many innovative teaching, innovative methods that we may have the practice between all the participants and with the resource persons. And moreover, a day by day, we will be having a new technology to have the interface and to have the knowledge sharing mechanism between the resource persons and my dear faculty members and all the participants to have the fruitful environment. And also at the end of the 6th day, the outcome of the session should be a valid and it should be a appreciable and it should be useful for research work and to bring the knowledge or to deliver the knowledge to the students. So we are concentrating in all the areas to make this better. So now I welcome Ms. Professor Vaishnavi Murthy Madam, a faculty of Computer Science and Engineering, SRM Institute of Science and Technology, to take over the session. Thank you. Unmute. Madam, please wait, ma'am. We will unmute you.
Good morning to one and all. So you're able to
Ma'am,
hear me?
your voice is not audible, ma'am.
So you're able to hear me?
I think that you may reconnect again. Voice is not reachable, that's all.
So you're able to hear me now?
அவங்க சைடு ப்ராப்ளம் இங்க ரெடி பண்ணிட்டு இருக்காங்க. இல்ல Vaishnavi madam, while you are speaking at the first it is audible, now only it is not audible. You may now it is not audible. I think that you may plug out your pins from the laptop or port and you reconnect, and in your desktop you minimize all those things. In your desktop it will be asking whether it is headphone like that. You please reconnect again, ma'am.
So now is it okay?
Yeah, super, ma'am.
Yes.
We welcome, ma'am. And your audio and video is clearly visible, and your screen is also visible to all the participants. You may start now.
Yeah. Very good morning to one and all.
Morning.
And it gives me immense pleasure to be part of this 6 days short-term training program on deep learning applications, challenges in big data analytics, series 1. And very much thank you to the principal of Velala College of Engineering and Technology and the Department of Information Technology for inviting me to talk under this AICT sponsored program. So today I'm going to brief you about, that is going to give you a roadmap for introduction to big data, machine learning and deep learning. So I thought I'll take it in a bit a different way, so that because there is a confusion, like always a confusion happens in these 3 words, but they take that it's synonymous in this, but it's not synonymous. Each one has its own features and perspective is different. So I would like to first make clear about all the terminologies in my session. And also I would like to throw some light on the research perspective, research directions under each thing. So I'm just getting into my presentation. So this will be my roadmap. So I'll be telling you about what is what. I'll be giving you a comparison between head-to-head comparison between especially the machine learning and the deep learning. And then the popular techniques and algorithms I'll be mentioning, though I won't be going in detail because you have the further sessions which will be handling in very detailed side, but I'll be giving you an outlook of each and every techniques. And then of course I'll be telling you the pros and cons of each learning techniques, why we are using, for what purpose we have to use. And then I will be ending my talks during this with the research directions, the possibilities of taking projects nowadays, that too we are in lockdown situation, and how the students and researchers can move forward even as sitting at home. I'll be just suggesting you few ideas. So I think I'll be switching off my video for bandwidth issues. So any questions you can, I think I'll take up the questions at the end of the session. I'll just finish my talk first, and I'll be very glad to go for a discussion after my talk. I'll keep it very crisp for 1 hour, so that we have around 10 to 15 minutes and so for discussion. And I would also like to have further discussion if you wish to continue even after the session is over. So, in the recent years, there has been a lot of buzz about the terms machine deep learning, data analytics, artificial intelligence, big data, etc. So these are all now the buzzwords which we are having this. So already a brief introduction is given by the faculty and principal sir of what actual deep learning is, why we require deep learning, why we require machine learning. So I would like to put it in another way. I would like to put it in terms of the daily aspects, the applications which we are using in our day-to-day life. So in this recent years, data scientists, data analysts have been named as the most sought jobs of 21st century. Most of the terms are seldom used interchangeably. However, each term, though related, is different from what they mean, and each opens a plethora of opportunities with respect to the various fields they can be applied to. So I think it's absolute coincidence that I'll be matching Principal Sir's words, and I would like to start from the mechanical department. So yeah, though I am from computer science department, like I have been into many interdepartment projects. So one of it which really fascinated me is the Industry 4.0. So being a member of the interdepartment project, so I would just like to start the session with Industry 4.0. So why I'm picking this topic is that I just want to tell you how we are evolving nowadays with the technologies. So in 18th century on, it was like just a mechanization. It's like just involving the steam power, weaving looms and stuff. The factories all were operated in such category. Then slowly they started focusing on mass production, where this assembly lines and electrical energy all started taking its place. And then they shifted in around 1969, the 1970s. They started automating. They started trying to automate, and the computers came into pictures, and many electronic devices started getting incorporated with the automation. And now, in the latest, I won't say today, I would say that like in the early 90s itself, we started off with Industry 4.0. But at that time, it was just an initial phase that we only the big companies, the biggies only, those who are dominating the markets alone, were into this automation and thing. But mainly they were focusing on cyber physical systems. So here the cyber physical system means, it means all the automation, right? If you take this Internet of Things, you take these smart sensors and stuff, all these things. So once you started getting these smart devices into picture, there arises the birth of huge amount of data. So all these things started off in early 1990s itself, but it took time. It took nearly a decade to get recognized within STEM. So you can see the transformation in this, how the mechanization and all this came into a mass production and assembly line with electricity, and then computer automation and robotics, and all this led to the pillars of the Industry 4.0. So once this Industry 4.0 started coming into picture, we started getting these terminologies, blockchain, big data, artificial intelligence, augmented reality, and machine learning. So we were all very clear about what is this augmented reality and virtual reality and all this stuff. But the thing is that still, though it has been like nearly 5 to 6 years where these buzzwords are into the your common colloquial language nowadays, and that too especially during this lockdown period, this has taken a different phase. It's like now it's only machine learning and big data and artificial intelligence, all these things coming. So when these words have started coming, there is still a confusion among many of the people, though even in students belonging to computer science or in information technology, they have this confusion, like what is what. They tend to, mix with each other, but they are separate. I told you, you have plethora of opportunities available for each and every terminology used. So another one thing after Industry 4.0, I would like to take you the example of today's shopping style. How we were started shopping previously, and today what kind of shopping we are doing. So I would just like to mention a little bit of retail evolution. So I'm just giving you these two case studies like Industry 4.0 and retail evolution just to tell you that how much data nowadays we are playing with data and how much data is generated and what is the need for processing those data. So here, initially, we started off making, we used to go to the shops, make request for the things what we had to purchase. And, it's like, like a small shop itself was used to be a very big thing for us. Like, because someone is coming and getting us the things. Instead of we going around, someone is coming and giving us the things. Like that only we started initially, our ancestors started. And then slowly, as the years passed by, in foreign countries, all they started getting the shopping malls. Maybe in India, we're used to shopping malls only from 2000 onwards. But before that itself, in early 1940s itself, we started having the shopping malls and thing where it was, a group of shops were available and we used to get many things in a single place. And then we started moving towards to the shops and stuff through transportation. So before it was very difficult for us to go to a place and get things, and slowly we started finding improvisation among ourselves. Like we started traveling there and getting things from there. And then whoever goes to shop only used to have that knowledge, what to buy, how to buy, when to buy things. But slowly, when TV and other radios all came into picture, came to our life, we through these advertisements on, we started knowing, oh, we have to buy these things. We have to if we buy these things, we can make our work easier like this. So many opportunities like where we are getting these things. All those things we started knowing. So these are all were the common life which our parents and everybody were facing it. But as we started, like the today's generation, they were like born with this computers and internet. So now they're starting itself, they know that everything you just sit at home in one touch, you're getting all the things available. What not? Whether you know what is available in Chennai or what is available at your place, today you know about everything where each and everything is available, at what cost is available throughout the world. So here the e-commerce has taken up a drastic, gigantic role of all these sales and things. So even nowadays we started getting things. We are sitting here at our home and we started getting things from abroad. All these products, so for example, the laptops and stuffs and everything, we started getting it from other countries also through all these online services. And just this e-commerce was getting into development phase, we found that the e-commerce, because there was a drastic evolution in technology, which led to the development of the smartphones. Because of the smartphones and smart devices, like the laptops, like the PDS, other PDS, we started getting this e-commerce. So when this e-commerce came into the picture, this in early 2000, we started getting this terminology, big data. So as sir mentioned already, like artificial intelligence, all took its birth in 1950s itself. In early 1950s itself, it took its birth. But the thing was that all this big data and the artificial intelligence and stuff, it started having its importance only once this e-commerce came into picture. And nowadays, today you see, and that way, especially in this lockdown phase, we are having so much of facilities. Like we can opt for Amazon, Flipkart, or like you go for online training, online payments, and everything. We're just sitting at home, and we are able to, get things whichever color you need, whichever however is comfortable for you. All those things with varieties and stuff, we are getting this with options. Maybe nowadays in a shop also we are having limited options, whereas in online shopping we have just unlimited facilities which are available for us. So you can see that how much data will be involved here. So this example I took in particular because now you will know that how much data is involved here. If you go for one online booking, you're getting those options. First, you're getting those options, you're getting the varieties, you're getting the rates to compare. So all these things are the analytics which is being involved behind. And then you go for the payment, you go for the orders and stuff, and there comes the other sector, the banking sector and stuff, everything. So you may not have cash out in hand nowadays. You can just, you can go for digital transaction and all those things. And for that, the information, whether you have paid, if you have paid means to track the products, all those things you would just imagine, even to know your location. How? In just you put a location. Nowadays, before you were typing your address, but nowadays you have a facility wherein just you get connected with a Google Map and you just pin the location as current location, and you just your address gets automatically saved into the portal and. So all those things, even a person who's coming there with your product to your home, he just tracks it with his Google Map and thing. So in this way, you can know that how much data is involved for just a purchase of a small thing. So these are all being managed by big data. And of course, behind the screen, you have this artificial techniques, which is playing a key role. So with this example, I would like to start with the buzzwords. Okay? So I would like to make clear with all those things, because today these are the latest terminologies which we are having. So it's like, data science, big data, data analytics, artificial intelligence, machine learning, deep learning. Oh no, what is this? These are all big words. And, and even those who are appearing for post graduations, you'll find that, okay, they even prefer, like, if they have specializations in this, they think that it is a very big thing. But it's okay. Even if you are having a core core department also, like IT or computer science or software engineering, we can specialize ourselves with all these techniques. Okay, so like for this, so this is the gist I could tell you, like how artificial intelligence and data science is being grouped. So in artificial intelligence, you have this machine learning and deep learning. So from this picture, you were just able to know that artificial intelligence is a very big circle which has applications of running through machine learning techniques and deep learning techniques. So from this itself, you could find that this yellow color wall is like, it is a little bit vast area coverage, whereas deep learning is completely focused. So when compared to machine learning, deep learning will be more focused and to be more specific. And data science, that's another terminology which is into boom, is the data science. So here, as you have more number of data, you are having more number of ways to just access your data. So data is just having all those all those techniques and stuff, which data you require. Because as I said, while sharing while purchasing a thing, you're sharing your details, your location details, you're sharing your bank details, you are getting the products. For that to get the product, you're viewing into number of this vendors, you're getting number of comparisons, rates and everything. So in this, so much of big data is available. There is numerous number of data is available. From that, you won't need a particular set of data. And to get that particular set of data, you have to know the analytics, how you can get that data. So whatever question you put, how you are getting that information through the system, all those things comes under the big data analytics. So I could just tell you, like data science is nothing but a combination of big data, how you process this big data, and then how you retrieve the data as per your requirements as data analytics. And now artificial intelligence is a combination of machine learning and deep learning. So these are the buzzwords which are like today revolving around us, and especially in the last 4 months, because of this lockdown, everything has got into digitalization, and these are the things which is just whirling around our minds, even in newspapers and other media. So there is a, there is a link from the previous slide itself. You would have known that there is a link between two. You have a link between the big data and artificial intelligence. So let's see how it is serving each other. So the big data describes a broad process by which we glean useful insights from huge data sets. AI applications describes one subset of such analysis in which programs use data to teach themselves to function more accurately on our behalf, leading to the improved business operations, service quality, customer relations, and so on. Today, you can see even in medical health also, it's like you started getting this online consultation and everything. So now, before going that, I would just like to tell you, like, the big data gives machines the volume and variety of data they need to make increasingly better and more efficient decisions in the performance of tasks. So if you just see, like, when a data is generated, it will be either in a structured or unstructured data format, and that how these data, whatever data has been generated from any source, how it is being stored, whether it is stored in large databases like relational databases or some cloud servers, what all these things we have to know so that it will be easy for us to get retrieve the data when required. So now we know that we are generating the data, we are storing the data, but how we are going to process it, how we are going to get it. For that purpose, we are going to use this artificial intelligence. So when we are processing this artificial intelligence, we should have to process first the CPUs or the GPUs, so that with the help of the artificial intelligence algorithms, and we have to fix with a pattern. And through that pattern, we should be able to retrieve the required data as per the requirements. And then once the data is being retrieved, we have to first predict, okay, how we are going to use that same data so that it can be converted into actionable insights. So what question we have here, how we are retrieving that data. For that purpose, you require this machine learning and deep learning techniques. So just before going to the terminologies, you would wonder why I have mentioned CPU and GPU. So CPUs, with CPU, you can process the machine learning techniques, whereas for deep learning, you require GPUs, graphical processor units, so that your voluminous data can be processed. So I'm just getting into the terminologies now. So big data. What is big data? Okay, data means big. Yes, it is big. So as the name points, data is big. So in simple words, big data is defined as mass amounts of data that may involve complex, unstructured data as well as semi-structured data. So it was difficult in those days to interpret huge data accurately and efficiently using the traditional databases. So traditional databases, it's like MySQL and Oracle and everything. But these big data tools then came into picture where it has become very easier to generate large amount of data. So for example, I'm just taking an example. I would like to take a variety of examples. So I've been already into this, retail industry 4.0. So now I'm jumping into a medical example. So, it takes years together to study about a genome. You take years together to study about genome before. But now, with the help of big data tools, you can just process that genome into just around, 7 to 10 days. You can study about that. So that's how the big data tools is playing a crucial role in processing the large voluminous data. So how big is the data? I'm just talking about big data. So how big it is? The next question comes. So it is not possible to put the number on what quantifies this big data, but it generally refers to figures around petabytes and exabytes. So it includes vast amounts of data sources gathered, and any corporate data, for example, you just take it, you'll get enormous number of data from its customers, its partners, this that is direct partners or channel partners, and then you'll be getting data information from its suppliers, and as well as as external data resources, media and stuff, everything for a corporate. So just imagine an example of Reliance company and thing. So much they have and so much data is being enforced into that corporate. So this astonishing growth of big data is because of this digitalization, because we are rapidly getting digitalized, and we are using this smart devices and thing to just to increase the voluminous data. Just 2 minutes, you use your smartphones, you'll be generating enormous amount of data because you'll be chatting with WhatsApp, you'll be chatting with Facebook, you'll be chatting through your emails, or you will be attending the phone calls and have more number of apps, or else you'll be playing games. So in just 2 minutes, you'll be generating a large amount of data. So these data can be structured into like structured, unstructured, and semi-structured. So these data, how they are processed, they'll be processed through this AI techniques. And one more thing, it's like data itself, it's nothing new. So here the big data itself, it's not nothing new. It's just that we are increasing the volumes. That's the most important. So I would just like to tell you, like these are the, you have around 10 V's, which is playing a key role for the big data. So one is the validity, variability, venue, vocabulary, vagueness, value, veracity, variety, velocity, and volume. So these many V's only make this big data. And how does big data came? Because nowadays our storage has transferred from the traditional databases to cloud. Now today, whatever you're doing, you're all doing only a cloud-based only. Let it be your emails. If you're using common thing, you're all using is Google Mail. So it's all going to the Google service. And that is the cloud service, Google Cloud is going. Whatever you're doing a purchase, whichever, like you want to watch a movie online, you're going for Amazon, Netflix, and Amazon Prime, or you're going. So all those things you will find that all these data are all generated from the cloud. And because of this cloud technology and things, this big data has taken a magnanimous role. And for this to manage, you have to have all these 10 P's. Those were the days where we used to, manage all our data through sheets, through the records, through the registers and things. Then slowly we started getting into the spreadsheets and things. But nowadays, we started archiving data into the cloud service. So here only this big data is playing a crucial role. And so how does this work? So before going to further, I will just mention you like unstructured means is like unorganized data, and this structured means is the data stored in a structured format. So unstructured data example, I could give you this videos, and structured data I could give you like the data which are stored in database management systems or the relational database management systems. And semi-structured is not fixed. It like has the properties of structured sometimes and semi-structured, I mean unstructured the other times. So the best example goes on with JSON formats. So a quick, a little bit of what is this called? So volume means, it's like, it's an anonymous volume. Nowadays we are talking about, the data is like, quintil tons, bytes are generated every day all over the world globally because everything is online now. And next is the variety. So different variety. Some are going by text, some are going by images, some are going by videos or voice messages. So it's like, variety is not the limit. You have excess of varieties which is being available. And next is that these big data, all these three V's will lead to the batch processing and stream processing. So it's like batch processing. What are these two terms? Like batch processing, this means that it is concerned by the volume and variety of data. So because we need to store this data and then process it, and then what you do is that you find a common application and you just retrieve the message. So that's called as a batch processing. So the best example goes on with the employment database. you already store it, you process it and you keep it. Whenever required, you just you write the details of an employee. And next phase is the streaming processing, where you will be having, like it will be just dynamic on time. You will just storing the data and you will be retrieving the data as soon as the data is being, acquired by the resources. So the best example goes on with the bank transaction. So bank transaction is dynamic. So you won't before itself tell that, okay, this month, this day, I'm going to I'm going to withdraw so much of money and this month. On the spot, if you're doing some purchase, means maybe you will be having a budget of 1,000 rupees, but you end up shopping, you'll be having some offers or something. You quickly end up with shopping for 2,000. Then quickly you usually you might have a pattern of shopping towards month starting or during the offers. But nowadays, like whenever thing is required, you just go for purchasing. So it's all like dynamic. So these type of dynamic data are all retrieved through the stream processing. So education institute itself, if you take like if you want to know about details about a student or something like that, it is a batch process, because already the students' information, related information, will be stored in that database, and from that you will be having these data which is being obtained. So next is that, so batch process will have the best examples of employment data, student data and stuff. And whereas in stream, you'll be having the online shopping as the best example. So next is I'm going to deal with the big data technologies. So they can be processed through using different tools. I've just given a rough a year, like how it all started off with 2000. I said that towards the end of the 2010 and this you first started having this big data technologies booming out, and this is hierarchical presentation to tell you like how in various years how the evolution of big data technologies has happened. So like you have all the technologies and the tools which has been mentioned. So these like from 2011 to 2018 still we are dependent upon the 2018 technologies and tools. So you could see that how it has been evoluted and how much is being used for us, so that we can process all these data which is just circling around us in different. Today like big data is in all walks of life. You take for medicine, you take for your own education, you take it for this other means like transportation. You just all go online and start sitting at home. You are able to do number of things which weren't like our hands were restricted to do before few years back. So this is just a glance. I know you'll be studying this in detail through the next sessions, but it's just a glance. How to just to know like how we have evoluted with our all data. So this is just a pictorial presentation I just got while just going through a few materials, and I found it a bit interesting. So you could just know like which are the storage things we are having, which are the analytical apps we are having, what are the visualization tools. So here in big data analytics, the most crucial thing which we are like focusing on is the visualization tools. So you just like, whenever you get some data, you don't go by the data, you go by the attraction of the data. That's the major thing. So you will be going. So why is that you are all like going for Amazon, you're going for Flipkart, you're going for this? Because something is attracting you. Maybe you are getting that offers, you're getting, some suggestions when you purchase a thing or this. This all because of this visualization tools. So in the big data tools itself, visualization tools only plays the most important part, where you can just, by using this visualization thing, you will again get this attraction. Even a person who's not like aware of, who doesn't have a background of any computers and stuff, is able to get into this, online mode and stuff and get all this. And even if you just ask a small kid, like when you were just if he or she, the small kid prefers only for normal rhymes or something, it won't be that attentive. If you just put that into with music or with some attractive cartoons or something, the same rhymes, it will be more it will more evolve towards that rise. The same way here also, when you are just generating your data, if you have it presented in a very beautiful manner and very attractive manner, you'll have more customers and clients looking forward into that data. And this is all a business tactics to just attract more and more customers. And other tools, and you have the distributions of the data, how these are all. So I'm very sure that you will be studying all these tools and technologies and during your other sessions. So it's just you. So these are the, the basic tools, the big data analytic tools, which is ruling the world today. And these tools have changed our lives in terms of this banking, media and entertainment, healthcare, energy and utilities. That is sitting at home, you're all paying EV bill today, and that too especially in lockdown. These are all it's because of this, big data analytics and this artificial intelligence, which is running behind the back, behind the scene. Manufacturing, education, transportation, and insurance, and everything. So today, actually, we have never realized like how the technologies have literally overtaken us. But these last 4 months, it made us realize that it has really changed our lives to the core. Education has not stopped; it has continued because of the online services and the bank transaction, everything you're able to go. Today, nobody is daring to stand in a queue to pay any kind of bill, let it be EV bill or gas bill or whatever it is. We are all preferring just to, through mobile phones or through online services, we're just acquiring those facilities. And even healthcare also. So I think now due to COVID and for this pandemic situation, now we are finding, we have many healthcare experts. We are having this mental health experts, everybody having consultations over online. So all those things, so that healthcare, it's just, we are saying that it's okay, a doctor, we are meeting a doctor, the doctor is speaking to us like this. No. It involves a lot of work behind. You have to first take appointment. If appointment gets recorded, first it cross checks whether the doctor is having the he is not having any clash with other appointments or this. Then the time duration, for how much time he has consulted, for that the fees you have to pay that. And suppose you need other consultation apart from the doctor whom you are approaching, then a connection has to be made to the concerned doctor or the expert so that you can carry forward the consultation. And when you carry forward from one doctor to other doctor, you may not repeat what is your problem. You might repeat it because for your own, to make sure that you are putting all those things in place. But the doctor would have already got the information from the previous doctor. So the message transformation takes place. And based upon that, you get the medications done. And nowadays in Chennai, you can find if you are like associated with Apollo Hospital, something, you get a periodic, a reminder saying that your 1 month of review is over, you have to come for another review, or else one yearly checkup. It's all you're getting all these details, through messages, SMS. So all these things are happening because of this big data and artificial intelligence. So my next topic I would like to jump is that machine learning. So that's the next aspect, which is the main thing happening. So it's like machine learning has transferred many aspects, like throughout our life, and that especially now in our day-to-day life. So we have just, if you could just realize, think back, you could realize how this machine learning has evolved. The past few years have seen machine learning emerging as the trendiest topics. And it allows like computer to find these hidden insights. That's a new thing, It has a major surprise, and sometimes it becomes shocking also how it retrieves the hidden insights from the voluminous data and without being explicitly programmed how we are to look into it. So sometimes when you just surf the net also, you start getting information which is like much more than which is like you expect. In that kind of you start getting surprising data, sometimes shocking data indeed. So these past few years, you will see that these voluminous data they are getting, synchronized, they are getting curated. I would say the term curated. So what do you mean by curated? It's that based on data in a proper structure, and you retrieve them whenever it is required. So whatever question you put in any search engine, for example in Google or this, you are getting the data which is being, for the question which you are putting. So if you have been like using this search engines for many years behind, you will know that initially we'll be getting a data, we'll be just putting a keyword. For example, if I say in Google, if I just type it as machine learning, I'll be getting the data of everything wherever this machine learning is being, attached to that file. I'll be getting all the files there. So it's like, you won't know what you're searching for. But nowadays, you're able to, define your search. You like machine learning. So it will itself, it will give you some suggestions saying that whether you require machine learning applications or you require the difference between machine learning or deep learning. Actually, while searching, you wouldn't have heard that, okay, I had to search for deep learning also when studying machine learning. But today Google, the search engines will give you suggestions. They'll tell you if you're studying this, you can read this also. So they will start giving you this idea. So this is the the evolution we are saying in this machine learning. And one of the exciting aspects about machine learning is that its applications are virtually endless. And in fact, it has been transforming a wide variety of industries in very interesting ways. Okay, even today, like computer science or IT student also, is keen into looking into Industry 4.0, which is completely associated with mechanical engineering. And it's like even when we are like into like aerospace, what is happening next? What is happening in medical field? Though it's not a part of our domain, it is making us to get involved into other information also. So now what is this machine learning? I told you before, it's a machine learning, it's an application, one of the applications of artificial intelligence, but the other application is the deep learning. So it makes the system learn, it increases the ability for the system to learn automatically without any human intervention. How much time you expect someone to keep on feeding data and asking the data to be retrieved whenever, however it's required. So this, you're just automating it, and in this way, you're improving the experience without without the programming. So once you train the data set, you train the system. You're expecting it has to give you the output whenever it is required. Okay. So the best example today, these are the examples where machine learning is playing, endlessly in all these applications. So I would just like to give you today's day-to-day thing. So Amazon, you already know, you go for the purchasing. Facebook, I think all of you are in a Facebook users. Maybe 1% won't be Facebook user due to maybe a personal experience, or maybe you're not interested in that. But 99% of the world is into the social media. And Spotify is the app which is being used for listening to music globally, and it has been it's been introduced by the Swedish company, the Spotify, which literally took the music into the next level. So you are able to hear any kind of music that in any genre. You are able to just look it, just have the app downloaded. It will suggest you if you are like into a particular music like melodious or some jazz music or something like that. It will suggest you what other related music you hear, listen to that. And Netflix, I think this 4 months Netflix has gone to some different level, because they were all like it shut down with all these cinema halls and other entertainment zones. So Netflix was the only savior for us, along with Amazon Prime and other thing. And then the so Uber also had its virtually endless application. Like you just put a map, you just put your location, pin your location, you will know how many cars are available and what is the rate. You can see the drop and rise of the rates, and you can book it accordingly. And while booking, you will know all the details about your driver, right from his photo till what is his specialty, whether he is like interesting guy to interact with, or whether sometimes we have drivers who are impaired with hearing and speech also. So we know about, before getting into the car itself, we know little bit details, not the complete details, but we will be knowing about the details about the driver, that is the space, match, everything we are having this. And next important thing, which is like day to day, we live into this, is the 7-day forecast. Will we get rain today? That's the thing. So it was like, 4 months before, everybody, including we staff also, we always we look forward. Okay, if it rains, we get a holiday tomorrow. So like this, once you start getting this, all this terminologies used, like you're getting some, monsoon set, you're getting the cyclone formed in Bay of Bengal, Arabian Sea, everybody will quickly rush to the news and they will ask, okay, they will just expect when that forecast person will tell you, this from meteorological department, when he will tell like, okay, it's going to rain heavy rains for next 3-4 days, then we quickly start looking into the news. Are we going to have our institutions declared for a holiday or this and everything? So how they predict that? How they predict like, okay, today it has rained. Okay, we can see it, it's raining. But how do you know like tomorrow also the heavy rain is going to come? And how do you know that okay, in 2-3 days, like how they want the fishermen don't go to the sea? How they're not gods, right? Nobody is God here. But how they predict? It's all because you already have a data set. So over the years, all the data is being collected. You're having a voluminous data which tells you like which month, when it rains, how it rains, if you have any special cases, like if it rains, for example, the December floods we had 3+ before, like it was unexpected. So all those data are all like, they are saved now. And whenever you get the similar situations, it's marked according to the rules and it will tell us, right, okay, if this rule is matching, for example, it is raining continuously for 4-5 hours means, okay, so these reservoirs will get filled. And if it gets filled, it might lead to floods. Like this, they start predicting. So these data all are predicted using the previous historical data. And with that perception only, you get the forecast for the future days, for the next 7 days. So that's why, like sometimes, it goes wrong when the rules, always the rule, the machine learning rules will not match. Sometimes it disappoints us by saying it will tell that tomorrow it will be a heavy rain, but once morning you will be equally waiting. Okay. We'll be getting a holiday flat, but quickly we'll find that the sun will be shining towards west. So that's sometimes it happens. Not sometimes, mostly it happens when we eagerly look forward for our holidays. But it's all because, but most of the things, like warning the signals during the cyclones, floods, and everything. These are all the data which help the the emergency teams and everybody to work in that place. So that's just examples you have in our day-to-day life. So this is a kind of data. So just to tell you a brief what is machine learning. So you have here, you see the left column, you have this apple, you have this broccoli, and you have grapes. Okay, it's like that data is having. So how different ways you can just segregate. I just need broccoli, I need broccoli, I need. So I just am segregating. Through K&N Hills, I could just say that I could separate these apples and broccoli separately and remove the grapes out. And if it's a vision tree, I'll be putting it as a hierarchical structure. And then I'll be retrieving only the broccoli thing separately. Or else if it is SVM, if it is support vector missions, I will be like drawing graphs and then segregating the required data, which is broccoli here. But the final question is that I'll be generating an algorithm to retrieve the data out of these 3 bunches and retrieving the data which is required to me. And that answer also is like I will already expecting that I should get this answer. And based upon that, I will be having the algorithm. So these are the common machine learning techniques. So again, I just like to mention it, though it's repetitive, that machine learning is just an application of artificial intelligence. So you have all these types of this, unsupervised learning, supervised learning, reinforcement learning, clustering techniques, classification techniques, and regression techniques. So I just like to give you a brief, what is unsupervised learning? So it's like, it's a computer program that can learn to identify process that pattern and relationship without human guidance, without human guidance. Whereas in supervised learning, you will be having, you will be having all this structured data. You train the computer for input and output, and based upon the training sample, you will be getting the outputs. Next, you have this reinforcement learning, where the system learns from the mistakes which has been done. So, you'll be having some unusual situations and instances. All those things will be entered as you come across it, and it will be retrieved so that again this situation happens, means those mistakes don't come. So it learns from the mistakes. And next is the clustering techniques. It's like it's an unsupervised technique where you don't have the labeled instances, but instead you'll be just referring to the clusters as a cluster you'll be having it. And next is the classification techniques, which will tell you like whether it is true or false or 0 or 1 value you'll be having. So this classification techniques is used is for the cancer detection or the tumor detection. For this type, you will be using the classification techniques. And next, the final thing is the regression testing. You have to know, like, everything till now what you saw, it was all quantity based. So now, like, how much, like, you have to answer even certain questions which are quality based, like how much, and does this certain type of through weight operations and parameters will be addressing the quality based parameters in regression techniques. So these are the major techniques under machine learning thing, and it has been branched. So I'll be showing you a branch of it. So before that, I would just like to know about the deep learning techniques. So here, now next topic is the deep learning. So you know about machine learning, you're training the system, you're getting the data as required as per the supervised, unsupervised or semi-supervised, reinforcement training and this and stuff. And what is deep learning? Deep learning, as you already had the introduction given by the introducer. And you could see that it is a part of the neural networks which is more specified, it's more focused. You're narrowing down your search and you're retrieving your message from that. So here, when it comes to narrowing down, it means that you're going to have layers and layers of networking structure. From that, you're going to retrieve your data. So this deep learning actually is starting through the medical research, and when they were just, they were doing the research over the brain, they found that, okay, why can't we describe this technique, deep learning, is more focused to the human brain. And so, because your brain has a layer of networks involved, and you have this neurons, everything, perceptrons and everything which is interconnected. So one is dependent upon the other. Even if one functionality doesn't function properly, even if there is a neuron or perceptron or anything like that, in the nerve cell or something like that, you won't have your brain functioning properly. Similarly, that same concept was taken for deep learning. So I would say that deep learning is an advanced form of machine learning which collects data, learns from it, and optimizes. And deep learning has also overcome the limitations of earlier shallow networks that prevented efficient training and abstractions of hierarchical representations of multidimensional training data. So these are the few deep learning techniques which has been done. And one more thing is that deep learning will be mostly vector. Vector means it's direction oriented. So now your brain, right? Even your brain, you take for example your brain. Today your brain is telling you to listen to this session. So it is, all the brain cells are working towards that for listening to this session. And you're taking notes if required. So all these things are all interconnected. But if your brain doesn't give you a proper instruction that what you have to do, you won't be sitting now and listening to this presentation. Okay, so the brain is telling you, okay, if this topic comes, you have to pay attention. You have to write notes. So something is giving you instructions in a very defined manner, in a directional manner. So that's why I tell it is vectorized. Okay. And each deep learning method will be having number of layers involved. And this key characteristic of this is the geometric transformation, which is differentiable. So each layer by layer, you will know what is happening and how the data is being transferred from one to the other thing. So this you could see a drastic difference between the conventional machine learning technique and now the latest deep learning techniques. Okay. So the best example I would like to go is for this Google Assistant. Right before you used to type your Android mobiles, you used to type whatever you require to do. Now, nowadays, Google Assistant is playing a very key role where you just through your voice recognition, it gives you. For example, if you want to set an alarm, if you want to call someone, or something like that, you just speak to the phone over the Google Assistant and it will help you to retrieve the data in a more efficient way. So that's the best example for deep learning method. It's a Google Assistant found in your Android mobiles. The next best example is the Siri app, which you find it in the iPhones. So that also helps you to, it eases out your search for any application in your mobile phone. And so here, deep learning constantly helps to cope up with the surroundings and make adaptable changes. This ensures the veracity of the operations, and to elaborate that, we have to have efficient problems. So now deep learning, I have told you so much about that it's more clearly focused. I've given you the apps, examples, and everything. From this, you'll be knowing that deep learning will be requiring more number of data, structured data, focused data, than the machine learning, and you need more extra volume of data to get a more efficient results. So I just like to brief you about these four methods: the CNN-based methods, RTL-based methods, autoencoder-based methods, and sparse coding-based methods. So here, in convolutional neural networks, that is CNN-based methods, you'll be having the concept of, instead of connecting to the neuron, how it is connected. What is your next step? How, when, from where the next data has to go, which layer it has to go, when it has to go. All these questions will be answered if you are using convolutional neural network. And if this is one method where you will just moving forward, you will be moving forward. What is next? What is next? What is next? So you'll be having a definite vectorized parameters through which you will be just approaching it. And next, in a way, they try to regularize the feed forward. That's what moving the forward. I would say that's feed forward networks and avoid overfitting. If you put excess of data which it cannot process, it will not consider. It will be having, though it will be processing the voluminous data, it will be having like the time to time, it will be having a section to which it will be just, it will be processing that data alone, that size of data alone. So the best example goes on with the video recognition, medical image analysis, and the self-driving cars, the new terms which has been introduced, self-driving cars. They're all use convolutional network-based methods. And next is the RBM, which is restricted Boltzmann machines. Restricted Boltzmann machines. So when you talk about this restricted Boltzmann machine, you'll be having this deep belief networks, deep Boltzmann machines, and deep energy models, which is playing a key role. So whenever you go for deep learning, it is like very necessary for you to learn about these deep belief networks, deep Boltzmann machines, and deep energy models. This is the most, the prominent ones which you need to know if you're going to a deep learning techniques. So in this, you will be having in this you'll be having multiple RBM schemes also which is available. So here you will be having like fully connected layers, but they differ in how they are trained. So in compared to CNN and RBM, this also is having multiple layers. But the difference lies in how they are trained in the previous pass. So following that only RDM will be trained its data. So it is based upon the previous data which is being available. Okay. And here in this they are able to come backward also. So you see then it is mostly about the forward, but in RDM you are able to just come back and go. So movement of both the direction forward and backward is possible. And next, the third one is the encoder based methods. So in this, you will find that it's a specific type of straightforward neural networks where you will find that you will be having a code that is compared to a summary or a compression. Okay, so it will be having a latent space representation, and it has three components mainly: a encoder, code, and a decoder. But mainly it is used for the data which is more specific. Lossy data, it reduces the lossiness of the data, and then it is unsupervised learning. And it is unsupervised learning. And next, the final thing is the sparse coding based methods, where it is all based upon a set of basic functions. So the set of basic functions, it means that it is all dictionary based. So like if we refer to the basic functions, which is grouped like a dictionary, from that how like if before on in search of a meaning, you just search into a dictionary and get the meaning done. In the same way, it will just search for its basic functions, and if it's available, the similar functions is available, it will be using that technique. Here and some examples I have given. So all the CNN based, RTL based, autoencoder and sparse coding methods, you have the examples which has been listed. So this is a difference between the machine versus deep learning in a nutshell I would like to give you. So it's like machine learning means it's just about the input, feature extraction, classification and output. So it's all happening in all the four stages. So to identify whether it is a car or not. But now in deep learning, it is just, it's like two stages. You first give an input, you have the feature extraction and the classification done and for anonymous data and more specific algorithms to be written. So that output is being obtained in a very shape. So you all were learning about this machine learning, deep learning and stuff. But I just like to learn because these are the things which you are able to, get point with a new terminology that is adversarial machine learning, which is still like, it's already been coined and people are working on it, researchers are working on it. But now, since these 4 months of lockdown, globally it is being done, you'll find that everything has been optimized, digitalized, and everything is online. Okay, so that arises the aspects of adversarial machine learning, where it will just take care about machine learning despite your cybersecurity attacks and vulnerabilities. Okay, in that specifically restrictions time also, this adversarial machine learning will take its role. So you have two types of it. One is a generative adversarial network, and another is the deep reinforcement learning. So I'm giving you one example about this picture where you could find that a horse is running. The same horse, it can be represented as a zebra also. So how does it make you different? Both horse and the zebra looking the same. But the zebra is being made. Actually, it should be identified as a horse. So this means that somebody has changed the thing, which like it's not able to, I'm not able to make a differentiation between a horse and a zebra. So this means it's like someone is being tampering my data. So for that purpose, I'll be using this generative networks. So this is the first example I would like to give you about the image editing, where you'll be having these drawings, paintings, and photographs are actually indistinguishable from the real picture. So if you just say this zebra alone, you won't know that it has been taken from the horse, unless until I say it is a horse, which is taken between two zebras. So for that type of thing, you'll be using this generative adversarial networks. Next is a popular game you all will be knowing is this arcade video games, right? You just moving the base so that you just catch the ball whenever it is on the ground. Okay, so this is because of the deep reinforcement learning, which exceeds the human performance on complex problems, includes arcade video games, and the popular, in the next example is the Asian started Go game. That also it's all based upon the reinforcement learning. Another is the safety driving in cars, automatic cars, where you find that if you're not putting your pen, you're increasing your speed, you're not increasing the relevant gear and stuff, everything. That time the relevant reinforcement learning will be coming into picture to do the performance. So this is adversarial machine learning, which is like divided into adversarial defenses and adversarial attacks. So what is adversarial defense? It means like that restricting the hidden space of deep neural networks. Deep neural networks are vulnerable to adversarial attacks, and you'll be having two types. One is the proactive, and another is the reactive defenses. Whenever you talk about any any optimization, you are having the attacks also, and then you have to simulate it about the defenses in both the systems. You have to take when you are using any automatic application, because we are having this big data and artificial intelligence running behind, which is governing you, in fact. So adversarial training, it means it generally uses the generated adversarial examples to retain the models, and it reduces the changes.
Vaishnavi ma'am, just a minute ma'am.
Yes.
Ma'am, your audio is not clear. It is showing a background noise. Kindly check your audio ma'am.
Ma'am, actually I am alone in the room.
Actually, your audio is like double voice is generating. Uh, Kindly check your background voice ma'am.
Now is it okay, ma'am?
Now also like that only ma'am. It is showing like more background voice behind you. Ma'am, have you stopped your screen share?
Yeah, I think it got stopped. Are
Okay
you
ma'am.
able to see the adversarial machine learning?
No ma'am. Okay, I will change you as a host. You can share it again ma'am. Okay. I have changed you as a host. You can share now.
You are able to see?
Yes, ma'am. Okay, it is visible. Okay, now you can change me as host again, ma'am. VCT STTP.
Oh. 169 Marjorie.
No, ma'am. VCT STTP.
Oh,
You can change that account as host now.
yes.
Okay, ma'am.
Now it's fine.
Yes, ma'am. Yes, ma'am. You can continue. Sorry, ma'am.
Yeah.
Okay.
Okay. So I was just talking about this adversarial machine learning, where you'll be having these differences and attacks happening. So as your machine learning is being processing your voluminous data, and even you're having your deep learning or techniques also playing a major role in all your data process, there comes a necessity to have your adversarial machine learning. So here, why? Because it mainly deals with the cybersecurity issues and vulnerabilities you are facing when you are processing this voluminous data. So for that, you have so this machine learning, this type of machine learning, it's a combination that deals with both your deep learning as well as your machine learning techniques. In order to overcome the drawbacks of the code, you're having this adversarial machine learning, which mainly takes care about your attacks when it's like the data is going to get hampered, or it's going to get attacked by your other outsiders or something like that. that time it will notify us and it will also help us to get ready with defenses. So you have two types of defenses. One is the reactive defenses and another is the proactive defenses. And then you have these adversarial attacks, like when weakening happens because of the volume of data present, like the location specific attacks, knowledge specific attacks, intent specific attacks. So these type of attacks are all taken care through adversarial machine learning. So this is another area of research which is it's just coming. It has already been introduced, but now again it has taken its new form. Because of everything getting technically dependent nowadays after the pandemic situation. So now adversarial machine learning is playing a very key role. So this I have just clubbed till now. So as Sir said that artificial intelligence was took its origin in 1955 by John McCarthy, and then you had this machine learning. And after very few years, in 2 years itself, you had this machine learning techniques, Arthur and Samuel. And these are the classifications you can find, like supervised, unsupervised, reinforcement learning, and representation learning. Under the representation learning, you will be getting all these deep learning techniques. And when you plug the supervised and unsupervised, you'll be getting a hybrid phase, which leads you to the other phase, directive or constructive learning. And alternate learning techniques, you are able to serve with the ensemble, automated, online, active multitasker, which is all the learning flow under the hybrid learning. So this table is just to give you a broader perspective of how this machine learning and deep learning techniques are integrated with each other, and what are the techniques you can use under each learning methods. So, for example, in deep learning, it's really dependent upon the convolution neural networks, generative adversarial network, and then deep reinforcement, and these are all the most prominent ones, which are all coming under deep learning, the self-organizing maps. So, but I would like to mention here, though, in deep learning, it's mentioned general adversarial network learning. It also contains a part of machine learning. So, always keep in mind that in artificial intelligence, you have machine learning and deep learning. But when you go for deep learning in particular, you will have the flavor of machine learning also. Because machine learning can't do deep learning. Okay, because you are just narrowing down and you're focusing, you're curating the data more through deep learning. So these are some online tools which I would like to suggest for the general analysis for this. We have Keras, TensorFlow, PyTorch, Scikit Learn, and this NumPy for high performance scientific computing and data line. Then SciPy is used for advanced computing, Pandas for general purpose data analysis, and Seqbon for data visualization. These are the most commonly type of machine learning and deep learning techniques. This today we are talking about subjects for processing the data. So quickly coming into the pros and cons of machine learning. So I just start with the most thing first. So it's easily identifies the trends and patterns, and then there are no luminous interview, and has complete computation improvement, and then you have this multi-dimensional, multi-variety data which is being involved, and it handles all those things and have huge wide data applications for this intervention learning. Whereas when you come to the drawbacks, you have this data acquisition. How do you acquire data? Where do you go for the data set? Because on this country you have a large data, you will not be able to process the algorithms more efficiently. You won't be knowing which is good or which is bad. So you require enormous amount of data. Next is time and resources. So sometimes you have to be dependent on this paid tools and stuff like that, so that your time also it takes a lot of time. Sometimes the data set is too huge and the volume is too fine. that it is all getting processed under the same technique. So time and resources all will be really challenging. And next, interpretation of results. So this is based upon the perception and predictiveness. So it's like how you think, how I think, it all depends upon that. So the interpretation of results also depends on because each one has its own perception. Because the perception difference, we will sometimes the results be wrongly interpreted. And next is higher error acceptance. So when you're carrying so much of data, even by chance you must any one thing because the data record from the data sets, you will find that it is highly, erroneous. It will be giving you a different, results than the expected ones because just because an error is being missed, that is a record has been missed by error. Next is the pros and the cons. So you'll be having the, this pros and cons of deep learning. We are having it as, the main point is like it is conceptually very simple, non-linear it is, and it can be fine-tuned and the more data can be extracted and you will be having multi-class problems which is being involved and you can solve it to the world class pattern recognition because it is the refinement of the deep machine learning. That is indeed it is the drawbacks you find in deep learning is that sometimes the query is misunderstood, it overfits, it needs regularization, and it's like very much data hungry. You have to have more number of data and then only to be learning it correctly and efficiently. For that, you have to require more and more data. So, which is very, very challenging if you want to go for deep learning. So, this I will end up with this. So this is the thing which is a small video I would like to play so that you have all these three technologies. You have the big data, the so-called data science, big data analytics, then artificial intelligence, machine learning, and deep learning involved in this. So this is a technology which has been introduced mainly for this pandemic situation. So you just go on with this. So with this video, you would be knowing that all the three are playing a major role in this. So when a person enters, it just senses it. It gives you like, the data analytics are involved. It will tell you whether the person can enter or not into that room. And then you have all the data which is being stored there because it gives you the thing that how many persons are entering and how many are exiting. And it gives you the warning. And for that, you have this machine learning techniques and especially the deep learning techniques also involved in this, which tells you like if more number of persons are inside, you are not permitted into the room. And then it just, when it comes and goes out, it will also records like how many times the person goes in and goes out and comes. And all these things, you can see a big data, a huge voluminous data is being stored, data has been generated through the sensors, which automates the door whether a person can enter or not, which is also connected with the analytics, which tells you like how many persons are inside and outside. And to process that, we are having this machine learning and deep learning. So this is the best video where all the three are integrated, and these are two research directions that you could work on all the three. The best example goes on with the smart city, where all these technologies are involved. And the question is up to you, like how you train yourself, whether to become a data scientist or you want to become a big data engineers. So it all depends upon where you focus, which part you focus. Whatever it is, focus on one thing, strengthen in that so that you can get out nice jobs, which is bus of today. So this is the most current trending topic, and you could work towards it and you get trained towards that, so that you can be a part of the latest technology technologies. So think big, start small, but please act fast because time is running, technology is just overtaking us. Many of them are upcoming with innovations, so before that we have to match them and improve them. So any questions you can just ask me. Open out for discussion. Any questions?
Participants, if any queries, you can ask. You can post your question in your chat box. Material will be shared in WhatsApp group later. Okay, I think no questions. Okay, thank you, ma'am. Thank you for your excellent presentation on introduction to big data, deep learning, and machine
Ma'am, I
learning.
have a question here.
Okay,
How to
you
process
continue,
big
ma'am.
data like stream or stored content. So it depends upon it depends upon the application you are using. Like if it's for an organization means you could just you can get the data you can always store. But if it's like current thing means you have to have the streaming data. For example, if you're going for online shopping or something means it will be streaming data because your prices, your products will keep on changing dynamically. That is in your organization, if you want the employees data or students data, if you want to have, it's already stored. It will be updated with occasionally and the updated data will be there. But that's the difference between the stream and the batch processing. Can you suggest stream for big data to process in stream? Yes, ma'am, I have already mentioned that here. We just have to show that. Suggest tools. So you can go on for this tools like you can you have this Hadoop for storage thing. You can go for this Kafka. You can go for this also Spark tools also. You can go for that, and then you can based upon the availability, you can just whether it's streamed or batch wise in this, you can modify your algorithms also in your big data analytics tools. Next. Any more questions? Okay, I want to buy a machine for machine learning. Can you suggest a machine configuration? So, if you have a good, simply it depends upon for machine learning means you have to first make sure whether you're going for machine learning or you're going for deep learning. First, you have to make sure if you're going for a machine learning, then a good CPU processor of good HGP like that, RAM and it's very good for any machine learning techniques. Okay, if you are going for deep learning techniques, especially means you have to particularly go for the GPUs. You have to go for GPUs, then on the graphical processor unit, then only you could go for a better processing. Else your machines will get hang. Just putting machine learning means it's. I'm just typing it in the chat box.
Okay, ma'am. Thank you for your excellent presentation on introduction to big data, deep learning, and machine learning. Thank you, ma'am.
Thank you.
Participants, please don't leave the meet because second session is going to start. Sorry for the inconveniences caused today. So I hope this will not get repeated in next session. Vaishnavi ma'am, you can leave now. Thank you for your wonderful
Thank you.
session, ma'am. So second session will be starting at 11:30 to 1 p.m. So many have posted that what audio is not clear. So hope we will rectify this one in second session. So sorry for the inconvenience, participants. Good morning, professors. On behalf of Department of Information Technology, Vellalar College of Engineering and Technology, we welcome Mr. K.S. Sabarish Kumaran sir, Product Development Engineer, R&D, Smart and Technologies, Chennai. He was the holder of India Book of Records on training more than 600 plus students in artificial intelligence. He is going to take a session on the topic of route to big data analytics. I once again welcome you, Mr. K.S. Sabarish Kumaran sir. Sir, you can start the session now. Participants, don't leave the session. So certificate is provided only those who are attending all the sessions. So feedback will be posted later. Uh, Mr. K. Sabarish Kumaran sir, you can start the session now.
Yeah, am I audible now? Just let me know in the chat box whether am I audible or not. So if I am audible, just say yeah. Okay, fine. So I hope the session will be interactive. So just be active in the chat box so that we are having some like mini events in this presentation also. So this might be helpful for you guys, for everyone. So let me go and start with it. So let me just go in. Yeah. So today we are going to see just an insight about big data analytics. Yeah. So I'll be starting with now. One second. Yeah. So these are my gurus, like Deepan Raj on the left side and the Jay Ganesh on the right side. They trained me on ML, deep learning, and big data, and many technologies they taught me. So they were very helpful for me. So just let me get started. Yeah, this is like when we just train more than 600 plus students in the like in the Tripadi college named SVW. There we train more than 600 peoples at the same time. So we were in the India Book of Records. So this is the India Book of Records event. So I said like there will be an event, right? So this is the treasure box. On the right hand side you will be seeing the treasure box, right? So this treasure box will be somewhere hidden in the other slides. So in upcoming slides the treasure box will be hidden. So the first person to find this treasure box and to just type in found it in the chat box will be getting a course worth like 2000. The data science course which we have in our portal will be given it for free. So just be active in this webinar so that you will be able to get a data science course for free. And only the first person who comments out just found it will be getting that this course, but not now. Like it will be in the upcoming PPTs. So whenever you find this box like this, so this box will be in two places in the upcoming PPTs or next slides. So just keep an eye on it. So what should you do is like you should just type in found it whenever you see a box like this. So okay, then yeah. So before getting started, like let me know what are the available storage devices in the market right now. So just let me know in the chat box. So just type in what are the like what are the storage devices available in market now. There is hard disk everywhere. So there is another thing like a hard disk. Can anyone just name it that? What is the device? Yeah, NVMe SSD, absolutely. Yeah, SSD. So what is the difference between HDD and SSD? Hard disk device is like, one second, sorry. So a hard disk device is like it will be having a speed of around copy speed of like 150 Mbps at the most. But whereas in SSD is like having a greater copy speed of around 560 Mbps, so that it will be able to copy everything with 560 Mbps speed at a speed of 560 Mbps, right? So this is the advantage of SSD. Also, like in HDD we will be using a magnetic disk to store it, but in the SSD there will be a different thing, right? So that is like a chip. So this is the thing which we have, like HDD is different from SSD. So these are the units which are available at now. So bit is like one of eighth of 1/8 of byte. So byte is 1 byte. So kilobyte is 1000 bytes, and megabytes is something like 1 lakh bytes. So the most highest storage is like yottabyte. So you might be thinking who will be using that yottabyte and all. So let me see about this in the upcoming slides. So okay, the data science, the term data science is being searched over internet. So I just went to trends.google.com and just took analytic of the data science. So you may ask like how they had this data. So how they know how many people search data science, how they know, how Google knew. So this is the question that might arise in your mind. So this is like Google will be just maintaining a great data of what we search and what we use. So they also maintain just they also follow their privacy policies, but they let us know that how many people have searched the term data science. So in January 2004, it was like around 50 lakh peoples, and in 2014 of October, there was a great peak in the search. So there it bloomed. The data science bloomed in 2014, and it is blooming still now. So why we will be going for data science? Sorry, data science or like big data, anything. So because of the growing datas, we'll be just switching to big datas. So you may ask a question like, what is big data? So big data is nothing but, let me just explain you with a small example. So let us take a pen drive of 16 GB. So we are just expecting the 16 GB pen drive to store huge data of 50 GB. Is it possible to just store a 50 GB data in a 16 GB pen drive? No, it is definitely no, because we can't just put a 50 GB data in 16 GB of pen drive. So what we will be doing is just splitting the data. So we are just splitting up the 50 GB data into two parts. Even two part is not enough. So we will be splitting up into smaller chunks. The smaller chunk is, we'll be seeing about the chunks and every other term in the upcoming slides. So just the big data is nothing but splitting up the data and just using it by smaller chunks. So that is the big data concept. So here, because of this social media, then tech giants like e-commerce sites, there was a huge growth in the data in the last 5 years. So when you see for um, a statistical company says every hour 500 hours of watch videos are being uploaded in YouTube. So do you just believe in 500 hours of data is being uploaded in YouTube? Yeah, it is truth. 500 hours of data is 500 hours of video is being uploaded in YouTube. So you may ask a question like, when we just upload a video, they will be just going through that background musics, and they will also be claiming something like, what to say, like they'll be also claiming for copyrights. Do you think there will be a human to just verify whether the music is being copyrighted music or something else? So there will not be any human. If there is an human also, it is impossible for him to just analyze, just watch every video for a hour. So for a hour, 500 hours of video is being uploaded. So will it be possible for a greater workforce? So it is not possible. So they have just analyzed. So here the big data plays an important role. So they have just had an algorithm. So that is the deep learning algorithm. They had just trained with the previous videos they are having, so that any video that is uploaded will be just checked by that deep learning algorithm. So that it will take around 2 to 3 minutes for a deep learning algorithm to just go through the complete video and check whether the music is a copyrighted music or the video is a copyrighted music. Sorry, the video is the copyrighted video or something else. So this is big data. So for example, let us take we are just sending messages in WhatsApp. So here when we see we are just sending many messages, and we get many forward messages. So everything is stored in somewhere else. So that is data center. So we'll be seeing about the data center in the upcoming slide. So these are the cause for the large growth of data. So here are YouTube, WhatsApp, Instagram, Facebook, Twitter, and many more are available in the internet. So here are the most contributors of the data: the Google, Oracle, SAP, and Yahoo is also one of the biggest contributor. So e-commerce, we will be also purchasing everything. So what happens is they collect every user's data, and then they process it. And they use it for some purpose, like personalized ads. So these are because of they are analyzing the data, so that we are able to get personalized ads, so that YouTube suggests you to watch other videos that is related to what you watch. So these are the things they are doing by using data analytics. Okay. So people say about big data. So torture the data so it could confess anything. Yeah, it is a truth. If we just go and torture a data, it would give anything what we want. We are having a face data of a person, so that we just put on an ML algorithm in it, so that we train the data of the face, so that whenever we implement it, we just implement the face trained data in a web camera, so that whenever the person comes in, it'll be just identified by the ML algorithm. So that is something like what this line says. So torture the data so it could confess anything. Yeah. So we'll be seeing a small video on Google's data center. So you'll be just overwhelmed to see a Google data center video. So yeah, I'll be playing this video.
Whenever you use a Google product, you're connecting to one of our data centers around the world. Let's take a look inside and see how they work. Google employees work here, keeping the data center up and running 24 hours a day. The networking room is the first stop on our data center floor. The equipment here routes requests to the right servers in the next room. These computers also allow our data centers to communicate with one another globally. On the server floor, powerful computers handle everything from billions of searches to hosting YouTube videos and protecting your email against viruses. We've custom designed these servers to be compact and energy efficient. To ensure you have access to your data whenever you need it, we keep each piece of data stored on at least 2 servers. We store another copy of the most important data on digital tapes. When a hard drive breaks, we erase all of its content. Then, for extra security, we destroy it with our disk crusher. The machines in our data centers are always working. Cooling towers like these pipe in water to cool them down and keep them running. When the water heats up, we pump it back outside where it evaporates. Now that you've had a glimpse, walk inside yourself. Explore a Google data center with Street View.
So you saw a video on Google data center. There they consider they have a large data. So what will happen if a single server is down? Do you think like that data will not be available anywhere else? No, it is like they'll have replication of data. The replication is nothing but a duplicate of data will be available at many places. Normally they used to have 2 or 3 copies of data what they have. There will be something like master node and there will be something like slave node. We'll be seeing it about in the upcoming slides. So why big data? Why big data evolved? So there is like something like RDBMS and Oracle SQL. Everything is available. Then why we gone into that big data? There is a biggest question in our mind. So we'll be seeing like why we get into the big data instead of the like former like databases or something else. So in databases, when we just type in a query, so there will be a large database. So think like it is around 10 GB or 20 GB something. Just think in 20 GB itself. So when we just query, only 30% of the data is visible for us and 70% is hidden. So the processing time takes a large time. So whenever in big data, it is like real time analytic. So there is not no hidden data. Everything is visible for us so that we can process everything. But in that database, that Oracle database or something else, the data will be stored in a single device. But here it is being split up and it is stored. The master node will have the metadata of the chunks whichever are available, that is being split up and that is being stored in a smaller systems. So then is to reduce the processing time, to handle large amount of data, to reduce the cost of processing. This is the important point. Like we need to reduce the cost of processing. So if we just run a database for a hour, there is power consumption and something else. So this is going to cost for us. So to reduce that, we will be going for big data. Yeah. So where big data is used? So for online transaction, that is being a secure platform, we'll be using database management systems. So that is like Oracle database or something else. We'll be using SQL or anything. So Microsoft database is also available. So we may use anything. So that is should be a secured one. So we are using database. and we'll not be able to store much data in that DBMS. So we'll be only storing the transaction details in that. So there is another thing like on analytic processing. So that is we'll be using for data warehousing, something else. So whenever we come to real-time analytic processing, we'll be using big data architecture and technology. Yeah. So whenever we come to real-time analytics, we'll be using big data architecture. Yeah. So here is a landscape of the companies that are using like big data. So here is like Oracle, SAP, Business Intelligence. So here is which are the companies that is using big data, and at the bottom you will be able to see like technology stack. So here is like Hadoop, MapReduce, Mahout, Apache Space, Cassandra, and many other things is also available. But here most of the people use Hadoop and Hadoop MapReduce because it is open source. It was developed in 2006, I hope, and it was developed by Yahoo, and it is donated to open source like Apache so open source. So any person can use without paying for it. But the thing is like we need a good system for using Hadoop. Like we need at least 8 GB of RAM, i5 processor to run a big data environment. Yeah. So here is what I said, like there is like 4.5 million data. Yeah, let me go and see the chat box. Yeah, 1 second. Yeah, who is the first? Vani Chakrabarti is the first to find the like the treasure box. This is a treasure box which I said earlier. So I hope every people is like attentive, so that Vani Chakrabarti is the winner for the first treasure hunt, and there is another treasure hunt in the upcoming slides. So just stay tuned for the upcoming thing. Let me note her name. Yeah. Yeah. Okay. So this is the thing which I said, like 2.1 million of data is being generated by Snapchat, and 3.8 million is being generated by Google, and 1 million of data is being generated by Facebook, and 4.5 million data is being generated by YouTube, and emails, 188 million of emails is being sent. So that's a lot of data. So we need to just analyze and we need to process these data. How? This is done only by big data. Yeah. So let's get into another slide. So this is the main concept of a big data. Whenever people just get into big data, this is the basic concept which we need to understand. So the 5 V's are volume, velocity, variety, value, and veracity. So let's see one by one about the 5 V's of big data. So coming to the volume is nothing but the size of the data that is being generated. There is a large amount of data that is being generated for each second. That is, whenever we use cell phones, the log files is being that is running at the back end. So that is always running. A log file will be just storing whatever the thing you are just seeing and whatever the thing which we have, and whenever an error occurs, that log is being automatically sent if you have chosen that to the device. If you are using a OnePlus device, that is being sent to the OnePlus people to analyze the data. So that is a huge amount of data that is called as volume. So next is like velocity, at the speed of the speed at which the data is being generated. So the speed is like something else. As I said in the earlier slides, like YouTube generates around 500 hours of videos that is being uploaded for every hour. So that is a huge amount of data that is being generated. So this is called as velocity in big data. Then variety. So there are different types of varieties of data, that is structured, semi-structured, and unstructured data. So here in this picture, you will be able to see like what is structured. Structured data is something like which we have in a specific format. A specific format data is called a structured data, like a relational database, Excel, or a table. So these Excel sheets will have a specific format for it, whereas in semi-structured data, it will not have much format, but a little bit. It can be stored in a database. That's it. So semi-structured data is like something email, what we write. So JSON file. If you have seen some JSON files and XML files, you'll know what is semi-structured data. So whenever we come to unstructured data, whatever I said, like log files, video and audio, does not have any format for it to store. So this is like unstructured data. So these three will be like mixed out in the big data. So it is hard to store in a database management system. So we go in for big data also. So veracity is like something like trustworthiness. So trustworthiness, you may ask a question like, what is it? Every data is being generated by individual, but some people, just to fool, they'll be just having some systems like they'll be generating the fake data. So that may not be useful for us. So for example, they have said like Twitter post with abbreviations, spelling mistakes or something else. That will be just messy data, like we'll not be able to analyze. So that might be a problem for us. So the veracity is like nothing but trustworthiness. So whenever we go in, let me say you an example. So take an example of hospital. Hospital is generating a huge amount of data. Like they'll be storing the patient's detail. So that is going to be a structured data. Patient details is going to be a structured data. Whereas whenever the patient just takes an X-ray, that is going to be an image, and the X-ray is unstructured data. What is then semi-structured data? The log files. When the patient when the patient goes out, that is called as semi-structured data. So this is like a real-time example. So value is nothing but when we process and when we just clean the data, then process it, then we use for just prediction or something else. The thing is like we'll be using for value insights or something. That is like value of the data. So here is the available frameworks of big data. So Apache Hadoop, Apache Spark, Cassandra, Hive, Storm, Pig, etc. There are many frameworks that is available. So many of the people and most of the people use Hadoop because of the easy support of this. Hadoop is being supported by many languages, like we can also use the Hadoop in Java. So it is being used everywhere. So why Hadoop? Hadoop is being created to process big data with reasonable cost and time. So this is the reason the Hadoop is being developed. Yeah. So here you see Dog Cutting. He was the developer of the this Hadoop. This was actually developed by Yahoo, and later in 2006 this project was just donated to the Apache Software Foundation as an open source, so everybody can use it. So there are many browsers, like what we actually use a search engine is like there is a video like how search engine works. In the upcoming slides you'll be able to see that video. So there are many search engines that is using Hadoop. So let me just list out some, like Lucas, Google, Yahoo search engine, Bing search engine, Nudge search engine. There are many other search engines which we will not be able to know. So these are the search engines that is, there is another engine like metadata crawler or something else. These are the search engines that existed before Google. So Google was like, and there is another fact, like you may just saw that Google page. So the Google page is very simple, right? So when we just go and search for like why the Google page is so simple, the answer will be like very curious to know, like because the developers at the starting stage were not aware of the HTML and CSS, so they made it so simple. This is the answer for the Google page is so simple. So this is the thing, like what we need to know. Yeah, so the milestones of Hadoop is like in 2008 Hadoop wins terabyte sort benchmark, and 2009 Auro and Sukwa became new members of Hadoop framework family. 2010 Hadoop's HBase, Hive, Pig and subprojects completed. 2011 Zookeeper completed, and 2013 Hadoop 1.1.2 and Hadoop 2.3 alpha has been released, and Cassandra and Mahout, many frameworks have been added with the Hadoop. Yeah, so here is the video, like how Google search works. So let us see this video also.
Every day, billions of people come here with questions about all kinds of things. Sometimes we even get questions about Google search itself, like how this whole thing actually works. And while this is a subject entire books have been written about, there's a good chance you're in the market for something a little more concise. So let's say it's getting close to dinner and you want a recipe for lasagna. You've probably seen this before, but let's go a little deeper. Since the beginning, back when the homepage looked like this, Google has been continuously mapping the web, hundreds of billions of pages, to create something called an index. Think of it as the giant library we look through whenever you do a search for lasagna or anything else. Now, the word lasagna shows up a lot on the web. Pages about the history of lasagna, articles by scientists whose last name happened to be lasagna, stuff other people might be looking for. But if you're hungry, randomly clicking through millions of links is no fun. This is where Google's ranking algorithms come into play. First, they try to understand what you're looking for, so they can be helpful even if you don't know exactly the right words to use or if your spelling is a little off. Then they sift through millions of possible matches in the index and automatically assemble a page that tries to put the most relevant information up top for you to choose from. Okay, now we have some results. But how did the algorithms actually decide what made it onto the first page? There are hundreds of factors that go into ranking search results, so let's talk about a few of them. You may already know that pages containing the words you search for are more likely to end up at the top. No surprise there. But the location of those words, like in the page's title or in an image's caption, those are factors too. There's a lot more to ranking than just words. Back when Google got started, we looked at how pages link to each other to better understand what pages were about and how important and trustworthy they seemed. Today, linking is still an important factor. Another factor is location, where a search happens. Because if you happen to be in Ormea, Italy, you might be looking for information about their annual lasagna festival. But if you're in Omaha, Nebraska, you probably aren't. When a web page was uploaded is an important factor too. Pages published more recently often have more accurate information, especially in the case of a rapidly developing news story. Of course, not every site on the web is trying to be helpful. Just like with robocalls on your phone or spam in your email, there are a lot of sites that only exist to scam, and every day scammers upload millions more of them. So just because instantvirusdownload.net lists the words lasagna recipe 400 times, that doesn't mean it's going to help you make dinner. We spend a lot of time trying to stay one step ahead of tricks like these, making sure our algorithms can recognize scam sites and flag them before they make it to your search results page. So let's review. Billions of times a day, whenever someone searches for lasagna, or resume writing tips, or how to swaddle a baby, or anything else, Google software locates all the potentially relevant results on the web, removes all the spam, and ranks them based on hundreds of factors like keywords, links, location, and freshness. Okay, good time to take a breath. This last part is about how we make changes to search, and it's important. Since 1998, when Google went online, people seem to have found our results pretty helpful. But the web is always changing, and people are always searching for new things. In fact, 1 in every 7 searches is for something that's never been typed into the search box before, by anyone, ever. So we're always working on updates to search, thousands every year. Which brings up a big question. How do we decide whether a change is making search more helpful? Well, one of the ways we evaluate potential updates to search is by asking people like you. Every day, thousands of search quality raters look at samples of search results side by side, then give feedback about the relevance and reliability of the information. To make sure those evaluations are consistent, the raters follow a list of search quality evaluator guidelines. Think of them as our publicly available guide to what makes a good result good. Oh, and one last thing to remember. We use responses from raters to evaluate changes, but they don't directly impact how search results are ranked. So there you have it. Every time you click search, our algorithms are analyzing the meaning of the words in your search, matching them to the content on the web, understanding what content is most likely to be helpful and reliable, and then automatically putting it all together in a neatly organized page designed to get you the info you need. All in, 0.81 seconds? Wow. Anyone else ready for dinner? Interested in learning more? We've got a whole website dedicated to how search works. Just click right here. Want to read the search quality rater guidelines for yourself? Click right here.
So this was a video which explains clearly how the Google search works. So let me just confirm like I'm unmuted. Yeah, I'm unmuted. Like this is how the Google search works. Like they said like ranking system. So there will be a question like how they rank it. So there is a framework like Spider which helps in ranking. It just crawls the data and the most visited pages and most highly just rated pages will be coming first. And recently they have they have introduced something like advertisements in Google. In past 5 years, they have introduced Google Ads. So they were just introduced the ads to be at the first at the top of the page. So they are just doing a business. So we'll be also able to see advertisements in Google searches also. So here is something you want to know. So this is the like Margaret Hamilton with who that like she wrote software that NASA's Apollo program had. So this is the code. In the right side picture, you will be able to see a stack of book. That is the code that was written by Margaret Hamilton. So this is the greatest thing that she has done. So she wrote a code to a book of Apollo guidance computer. So here is the largest data that is being processed, and the Apollo program sends back a large amount of data. So the process of the processing the large amount of data is done by big data, of course. So this thing is being simplified by using Python nowadays. So Python has a large frameworks and a large library support so that we can reduce the number of lines of codes. But this was in the early 1970s or 60s, I hope. I exactly don't remember the year which she wrote the code. So let's just get into Hadoop. So Hadoop is nothing but an open source software that supports data intensive distributed application licensed under the Apache V2 license. So the Apache V2 license is open source license so that we can use Hadoop without any cost being paid by us. So there might be a question like how might I install the Hadoop in my system, and how to just do this big data works in my system. So it might be possible only if you have a greater processing speed computer like i5 and upcoming versions like i7, i9, and a minimum specification of a RAM at least of like 8 GB or more than that. So even that 8 GB will not be enough for the Docker to run. So we'll be using a Docker to install that Hadoop frameworks. So Docker is nothing but like it is like Anaconda Prom for the Python, which is helping, or else like a pip packages in Python packages installer, like which helps us to easily install the Python packages. Similar to that we have for installing Hadoop is nothing but like the Docker. So the Docker is itself is like running on a virtual machine. So we need to just allocate the memory of RAM that is going to be used by Docker. So at least 4 GB RAM should be allocated to the Docker so that it runs without any interruptions. So the image file of the Hadoop is around like 11 GB. So we need to just download the image file of the Hadoop from the Hortonworks website. So the Hortonworks is the provider of this Hadoop as a free software. We can download it from Hortonworks. Just go to the Google and just type in Hortonworks Hadoop framework for Windows 10 or Windows 8 or Mac even. So you will find the Hortonworks image file. Just use Docker to install this Hadoop framework. Yeah. So the goals of Hadoop is to abstract and facilitate the storage and processing of large growing data, that is like structured, non-structured data, and even the semi-structured data can be stored in Hadoop without any like any interruption phase, any anything, nothing will be faced by the Hadoop. So it will be easy to store structured data, non-structured data, semi-structured data. Whereas in RDBMS, it is a tough job to store an unstructured data. It is simple programming models. As I said, like it has many support for languages like Java, Golang, Python. Everything supports this Hadoop. So Java is a scalable language so that we can use it for just doing this big data process in using Java or something else. So it has high scalability and availability. Use commodity, like it is cheap for like hardware with little redundancy. So it is also for enterprise. We need to just pay a cheap amount. So for this is for enterprise, whereas for personal use or the educational use, we don't need to pay anything. So it has like a lesser fault tolerance than any other frameworks available. And then the computation, like it depends on computation rather than the data available. So this computation, this is the goals of Hadoop. Yeah, here this is the general architecture of a big data. Here you see like a single master node. The single master node is also say like master node is also called by other name like name node. It is the resource manager. It consists of the complete metadata and the complete like map. It has complete map of the like what to say, like every data that is being in the slave node. So slave node is also called as data node. The slave node consists of a data node, like the data that is being stored, and there is a node manager, and there is something like map and reduce. So you'll be seeing this in the upcoming sessions, I hope. In the lesson plan I saw that there is something like Hadoop. You'll be getting hands-on Hadoop even. So here the map and reduce is nothing but like for mapping and reducing the, like there will be repetition of data. So to reduce that, they will be using reduce or something else. So I'm not going much deep into this by explaining every concept. So I'm just giving an overview of what is big data and how the architecture of big data will be. So here in the master node, there is only one master node, that and the master node is very crucial. So there will not be any substitute of this master node. So there is only one master node available. So we should not make it down. So always the master node must be up. So if the master node fails, then we'll not be able to get any data from the slave node. So that is the thing we have here. So like a slave node consists of the data node, node manager, and the map and reduce. So here you see like a data node, right? So this data node, let us consider like there is data like A and B. So in the first slave node, if you consider, the A and B will be present here. So here in the second slave node, you will be able to see like one second. Yeah. So in the second data node, you will be able to see like A, B or C and something else. So there will be something like replication of data. So that one, if one slave node fails, so the data will be served from the next slave node or the replicated data node. Data node. So this is the thing of slave node, but whereas in master node, only one master node is available. So this is the crucial data, the crucial resource for the big data. Yeah, the master node will not contain any chunk of data. Only the metadata of the slave nodes will be available for the master node. Yeah. Okay. So here is the typical architecture of Hadoop. Here, as I said in the previous slide, name node and data nodes are the main two things. That is, here is the name node, and here you see like the data nodes. Here something like they have a rack structure. So here is another rack structure. So here might be a replication of data. Here they say like replications, right? So this data is being replicated in the rack too. So this is called as replication to avoid the latency of the data, to just to avoid we don't get any data when we just post a query. So this is the thing we do in this data nodes. But whereas in the name node, only one master node is available. We only consist of the metadata and the map to the slave node. So that this is the crucial resource. The name node is very crucial. Yeah. So here there is another question like if user data is being collected by the Google data center, so will my data will be secure, or it is being visible for all the people who use who access the Google data center? So that might be a question like if a Google like let me take an example like if I am a Google employee, will I be able to access the personal data of the people? There might be a question like will I be able to get into the Google data center, right? So let me show you a video and just explain you that how secure the Google data center is. So let 1 second. Yeah. So let me just play this video.
Hi, I'm Stephanie Wong, and I work for Google Cloud. While I could talk all day about cloud security, physical security at a Google data center is still pretty new to me. So today, I'm on a mission to learn all about it by taking an inside look at the systems in place that protect customer data at a typical Google data center. Let's go.
Now, I've been told there are 6 layers of security here. Security layer 1 refers to the property boundaries, and that includes signage and fencing. But things really start to get interesting when it comes to layer 2, also known as the secure perimeter. And that includes the main entrance gate, which I am pulling up to right now. Hey, how's it going?
Good morning.
So layer 2 has a lot of security features, ranging from smart fencing to overlapping cameras to 24/7 guard patrols and more. I'm on my way to meet some experts who are going to show me how it all works.
Hi, Joe.
Hi, Stephanie. How are you?
So I just passed the main gate, and I saw guards and cameras, but what are some things that I didn't see?
Yeah, there's actually a lot of technology and operations going on behind the scene. So from the time that you're on site, we know that you're here, and we're able to do correlation analysis of where you've been. We have guards in vehicles. We have some guards on foot. There's also the vehicle crash barrier. That's designed to stop a fully loaded truck from crashing through the front entrance.
Ricky, Tariq, can you tell me more about what's unique about the fencing?
This particular fence is an anti-climb fence. It's also equipped with fiber. The technology tells us if someone's near the fence or touches the fence.
So we use thermal cameras and standard cameras, so we're able to see video footage at night just as clearly as we can during the day.
Welcome to layer 3, building access. But just so you know, I am still nowhere near the data center floor. That's a few more layers deep. Let's head inside.
Stephanie, so you've gotten through the gate, you've come into our secure lobby. You have your card, and we know that that's you, but if someone happened to lose their card, what we want to make sure is that it's actually Stephanie who's shown up.
Place into your eyes.
And with iris scan, we can authenticate that it's actually you along with your ID.
Okay, I think it's good.
One thing that's a little hard to get used to when you visit a data center is for secure areas, only one person is allowed to badge through a door at a time. Layer 4 includes the Security Operations Center, or SOC, a hive of activity that is monitoring the data center 24/7, 365 days a year.
So it sounds like we've been keeping them very busy today.
Yes, you have. So the doors, the cameras, the badge readers, the iris scan, everything is connected here. This is the brains of the security system. So if there's anything out of the ordinary happening, they have to be able to pick that up.
Interesting fact about Layer 5, the data center floor. Less than 1% of Googlers ever get to set foot in here. So right now, I'm feeling kind of special.
This is truly a as-needed only access area, meaning that only the technicians and engineers that have to be there to maintain, upgrade, or repair the equipment are ever allowed there.
And do Googlers or anyone have access to the data?
We have access to the devices, but the data at rest is encrypted, and our customers can issue and keep their own encryption keys. And we do this because protecting the privacy and the security of our users' data is our highest priority.
The mysterious Layer 6, where disks are erased and destroyed, and the fewest number of people are allowed to enter. Drives that need to be retired from the data center floor come into this room through a secure two-way locker system, which means that only technicians assigned to this room can pull them from that locker to either erase or destroy them.
All right, welcome to the Crusher Room. Wow. So at this point, we have scanned the hard drive and the software has told us that we need to destroy it.
Can we see it in action?
Back up.
All right, I'll stay back here. That disk is definitely destroyed.
Yes, it is.
If you didn't think these 6 layers of security were enough, Google Cloud actually has 2 security testing programs in place. One hires companies to try to break into data center sites from the outside, and the other tasks Googlers with trying to break security protocols from the inside. And getting out of a data center is arguably even harder than getting in, as everybody has to go through full metal detection each time they leave the data center floor. Google Cloud supports compliance with over 40 global standards, regulations, and certifications. And the commitment to constantly test, optimize, and improve systems makes it a leader in data center security. Now, how do we get out of here?
So here you saw like the 6 layers of the that Google data center, 6 layers of security they have. They even hide the cheaters who break through this security system to just avoid the thing to happen in the upcoming days. So this is the security system of the Google data center. So even a Google employee couldn't easily enter the Google server room or the data room. So every data is being encrypted and the encryption key is given to the user. So we don't need to worry about the data theft or data something. So the data is completely secure with Google. So they even destroy, they have a specialized software to destroy the hard disks. So like there is something like hard disk or SSD, they will be using a software to analyze whether this SSD or HDD can be reused or not. So the software will say like they need to destroy it or they can reuse it. So if they need to destroy it, they just completely crush it into a machine. So just they put it in a machine and the crusher just destroys everything. So that is like something fascinating. So these are the 6 layers of security that is followed by Google's data center. So as I said in the previous slide, like there is a name node. The name node stores the metadata for the files and it is following a typical file systems. So here we don't have HDFS, which is called as Hadoop file system. Yeah, it is just using a typical file system on which the Hadoop environment is being run. So if you run Hadoop environment on the Windows system, a Windows file system is being used. If you run this Hadoop environment over a Linux system, like a Linux file system is being used. So there are various file systems like FAT32 or FAT64 or something else, NTFS, or there are many things like file systems that is being used. So the server holding the name node instance is quite crucial as there is only one. This is what I said, like only one name node is available and no replication of name node is available. And the important thing is like name node only consists of the logs, how to say, like only the history of the data that is being entered. If the file is added, the transaction hash code will be added to the transaction log. Only that data will be stored, and not any chunk of data is being stored in this name node. And only the files adds and deletes are being stored as a hash codes, so that it will be encrypted. We will not be able to unencrypt, or only the person who knows the hashing technology and what hash is being used, he'll be able to just verify whether thing is correct. So there is another technology like this Hadoop concept that is called as blockchain. But whereas that is a thing different, where it has how to say, the blockchain will be consisting of different the same structure of a Hadoop, but the persons will be able to just verify the transaction is correct or not. Here only the verified persons will be able to clearly verify that data is correct or not in the Hadoop structure. Whereas in the blockchain structure, every user can just verify the transactions. So that is visible to all. But here in the Hadoop architecture, it is just known to the person, authorized person only. So it also handles how many data blocks is to be created, the replication of how many blocks should be created and how many should be deleted and how many should be repaired. It consists everything, every data of the slave node. So when we come to data node, it is an actual data that is being stored in the HDFS. HDFS is nothing but Hadoop file system. So there are various file system. As I said, like the master node will be running on any file system like ext3 or 4 NTFS or a FAT32 or etc. So the file system of the master node is different, whereas in the worker node is something like HDFS. So name node is something block that consists of the original data, and it is being replicated as a rack. So there usually people just replicate 2 to 3 stacks. So 2 to 3 replication is being done, and separate tracks is being stored. Once server fails, the replicated data serves the data that is being queried. So the master node will make the person to know that in the first track some server is down, so just repair it. So the master node will be notifying the person concerned, so that the person will be able to find that server is down, we need to repair it. Yeah. So as we saw in that Google search engine, how the Google search engine works, the indexes is the main concept how the Google search engine works. Like there are 3 different indexes in Hadoop also. So Hadoop ++, where a separate index is given for each HDFS blocks created. So a separate index is being given for every HDFS blocks that is being created. So there is another thing like Hail and LIAH. So Hail is nothing but Hadoop aggressive indexing library, whereas a cluster index is given for HDFS block. So HDFS block, a certain so consider like for rack 1 index is given, for rack 2 another index is given. So a cluster of HDFS block is taken and it is being indexed. Whereas in lazy indexing and adaptivity in Hadoop, it creates an adaptive index based on the query. So there is no no index is being constructed beforehand. Only when the query is being put on, the index is being created. So Hadoop ++ and Hail is most used indexes in Hadoop. So here is the interesting fact. So how many here know GitHub? So just let me know in the chat box. Have you heard of GitHub and have you used GitHub? So let me know in chat box if you have used GitHub or heard of GitHub. Just type in yes in the chat box. So let me know. Yeah. So there is many yes. So many people know about GitHub. So how many of you here the known people of the GitHub? How many of you here have heard of Arctic region? Like they have just initiated a campaign to just store the data in the Arctic code vault. How many of you here know they have a Arctic code vault? So let us see about video on the Arctic code vault that is being done by GitHub. Just recently they have launched this Arctic code vault campaign, and if we have participated in that campaign, our code will also be in that part of the Arctic code vault, where the data will be maintained for next 1000 years without any deletion of data or anything. So there is something interesting. So let us see this video and let me know this. Yeah.
Deep in the Arctic Circle, an archipelago covered in ice, Svalbard, home to the northernmost town in the world, to thousands of polar bears And it is here you can find the Global Seed Vault. Millions of seeds have been sent here from across the globe for secure long-term storage in cold and dry rock vaults. Just down the road is a decommissioned coal mine that has taken on new life. This is where we will protect open source software for future generations. Deep within the permafrost layer, which can stretch up to 400 meters thick, we will store the world's open source software on silver halide film. The data is encoded on frames with 8.8 million pixels each and designed to last over 1,000 years. In our initial deposit, we archive thousands of the world's most depended on open source projects. The work of hundreds of thousands of developers from around the world. We will return next spring, during the perpetual light of the midnight sun, to deposit every active public repository on GitHub for safekeeping in the GitHub Arctic Code Vault.
So this was called as archive program of the GitHub Code Vault. So they will also be just considering the active repositories in GitHub, and they will also be just taking that repository and putting it into the Arctic Code Vault, so that the repository can live for the next 1,000 years. That is something very interesting, and we'll be just living for 1,000 years even after we are just out of this year. So our names will be known even for the next 1,000 years. So that is very interesting, right? So just maintain a repository so that and also just keep that repository very active, and just and give enhancement to the repositories, so that your repository also will be added to that code vault, right? So okay, so we just moving on. Sorry. So here is another DNO fact. So like recently, OpenAI, that OpenAI is a startup which was just started. I hope it is being just in the last 5 years. It is being just run by Elon Musk. So recently they have released a module named GPT-3. So how many of you here know about this GPT-3 or heard of the word GPT-3? So let us see how many people know about this GPT-3. So if you know GPT-3, just type in yes. If you don't know, no problem, just type in no. Yeah, okay, no. So not every people will be knowing about everything. There is no problem in just saying no. Yeah. So this is very interesting. Like if you see the applications of GPT-3, you will be very fascinated. Like something else, it is just a threat of losing jobs of the web developers even. So let us also see a video on the GPT-3 module. I have consolidated in the single video around of 7 minutes. So I'll be showing you that video after the slide. I hope I have that video. I hope. So let us see. So you may ask like, what is special in that? So will you just accept that if I say like 1.75 billions of node is being consisted in this GPT-3 module? So if you think like a deep learning model consisting of 1.75 billions of nodes, that is quite very interesting, right? So a deep learning model with 1.75 billion nodes can do anything which we just queried. So this was being trained by OpenAI. It took like around 1 year, I hope. I don't know the time span which took by the GPT-3, the OpenAI to train this model. Just go and Google it to search about this GPT-3 and know how many months it took to just train this model. So they were just processing over the complete Wikipedia and complete models, like a complete data set. It was very, very huge. Like even we couldn't imagine that huge amount of data. So that it has a good accuracy in the natural language processing. So let us see something about this GPT-3 model. This GPT-3 comes in 8 sizes, ranging from somebody have told, I hope. 1 second. So again, here it is like Shailendra Singh. Let me note him. 1 second. Shailendra Singh. Here if you see, like there is like it comes in 8 sizes, ranging from 125 millions of parameters to 175 billion parameters. It is the largest language model ever created. So it can perform any tasks without any special tuning. So if you just train with a single data, that is very much enough for this GPT-3 model to work very fine with the accuracy of 95% plus. So we'll be seeing about the applications in the next slide. So it is a 7-minute video. Just please bear with me to see that. It was just very interesting for me. So I just consolidated that video into 7 minutes video and I have given it for you. Just watch it.
So the first example is an application called Figma, and the developer has built a plugin to Figma that allows users to enter a description of what they want for an application. So in this example, a user is describing an application with a feed and some icons and a user interface. And when he hits submit, the application actually generates an application that looks very much like Instagram. It has all of the buttons, all of the UI, and a scrolling feed. Just astounding in terms of what it's able to do. The next example is a coding example, and so this is dbuild.co, and they're describing an application that is a basic to-do list application. And so what the software is doing is it's generating a React application, all of the functions and procedures, all of the things that are necessary to create a React component to handle to-do. And you can see it works. You can add items to the to-do list. There's all the events and triggers for handling the interactions of the application, and it's all generated on the fly by artificial intelligence. Just amazing what we're able to do with AI, both design and development aspects. The next example is in Excel. And so we have a table with headers of company, ticker, and year founded. And we ask OpenAI to complete the table, and it's able to fill in the entire table with the data that it thinks we want. Again, it's pulling this information from its corpus of artificial intelligence, and it's trying to be predictive in terms of what it thinks we want in the table. If we don't agree, or we want to train it a little bit differently, we can queue it with different elements that start in the table. So here I actually want the table to be filled in starting from the newest to the oldest. And so I put Twitter and Facebook and then ask it to predict the table. And it's able to understand what I'm trying to do, and again goes top to bottom all the way in, filling in the year founded information with all the company information. So this example is within Wikipedia. So if you've ever seen a long article, you can't really understand or find the information that you need, you can simply have a plugin where you ask the exact question that you want. So in this example, I'm asking, why is bread fluffy? And it's searching the data and information in that article and generating an answer to my question and giving me a citation and location that I can jump to. So really summarizing the data, making it really easy for me to find exactly what I want from large volumes of text and information that are presented. Because of the vast amounts of information within GPT-3, you can really ask it anything. In fact, you can almost use it like a search engine where you ask it a question, it can give you one result, giving you the citation of exactly where to find that answer. So Google and Apple and Amazon have thousands of engineers working on this problem, and we're able to use this artificial intelligence to solve a very similar problem almost instantly. Just amazing what you can do with the tech. One of the common applications of GPT-3 is translation. So here we can give it an example of an English sentence that we want translated. Your order will arrive in 7 to 10 business days, and ask it to translate into French. We can also use translation to translate things that are written in legalese, this is an NDA, non-disclosure agreement, and translate that into something that a second grader would understand. People can speak in plain English, and the artificial intelligence is able to translate that into command line tools that are needed to run a Linux operating system. So instead of an esoteric command, you can just say things like list files recursively, and it knows exactly what to do, or list files in a human readable format, and it's able to return those results as well. There's lots of other applications for the technology. You can use the artificial intelligence to generate quizzes based on information that you have, so it can generate vocabulary or questions and then show you the context of where it's getting the information for the quiz that it's generating. It can also be used for entertainment, such as role-playing and generating a story with multiple endings or multiple directions in which you can go. A really early exploration of what the technology is capable of, but gets your imagination going in terms of what's possible. This week using GPT-3, and the idea of the dictionary is it's able to use context to give you the definition of a word. Most of the time a dictionary just gives you definitions for different words that you look up, but here you can actually see that you can give it the context of the words, the bark of a tree, and then it'll give you the definition based on the context of that word. So this is an example of an image recognizer. It's using a combination of image recognition as well as GPT-3. So it's recognizing the ingredients on a package and then able to tell you whether those ingredients are good for you, bad for you, or what they actually come from. So here we see it's identifying the ingredients, it's able to find those ingredients, it's actually looking up emojis for each of those ingredients as well, and able to give you a sense if those ingredients are good for you or bad for you. Another example of GPT-3 doing layout for design, and here a designer is asking for a button that looks like a watermelon, and it's generating the CSS for creating that button with the text inside of it. A button for every color of the rainbow, and it automatically produces a design that satisfies that constraint. A table of the richest countries in the world with column names and GDP. So a little bit of editing and polish. Let's see if that fixes it. It was close, but the autocomplete isn't perfect. And again, we really need to be thinking of this as a very sophisticated autocomplete. So it's not going to replace designers or developers. It's going to produce the beginnings of something that's incredibly useful, but it doesn't really have testing or quality associated with it. It's still up to skilled developers and designers to make sure that they use this as a starting point to produce something useful and to produce something that is well tested. So here's another one that I really like. This is a quote engine, and you can just hit refresh and it will give you a new quote every time. A bad question will beat a good answer every time. Tradition is by definition progress against the odds. The environment shapes evolution and the economy shapes society. Ultimately, evolution shapes everything. So let's do it right. Couldn't agree more. Good job, AI. And here's another design example of using text to UI within Figma. This is a variation of one of the things we saw last week. So in this example called Magicify, he's able to produce the beginnings of a web page by producing sections of that web page one at a time. So he's able to give testimonials or logos, placeholder graphics, and the UI is able to generate the beginnings of those designs. So for the developers out here, here's another technical one where you're able to type in a sentence and GPT-3 is able to produce an artificial intelligence-based SQL query that actually works within a SQL database. So really cool example of a technology.
So here is the applications of the GPT-3 module. But you may ask, like, will I be able to just build with using GPT-3? There might be a question, right? So since like it is being in a developing stage, it is just a private API. There is sorry. So there is like a private API form, so that if you fill out the form and your like application is going to be something useful, so they will be just providing you the access to that API, so that you can also build that model using that GPT-3 model. So you saw like the web designing. It could also say a story. It could just build the SQL for the thing which you give it. It could just write a React query, a React script, and it can do many things. So it can also just be as a assistant, health assistant for you, so that it could just read what are the ingredients and say you what is healthy and what is unhealthy. So was that very interesting to know about this? So just So say me in that video, like was it very useful, or it is just I have seen it earlier. So just let me know. So okay, let me, I hope that that video was very much useful for every people. So I have worked on a like a big data project, like where I have been analyzing the real time aircraft data. So I have been just analyzing the real time aircraft data to just build a performance model for the aircraft, so that it could just analyze, uh, find the trajectory of the airplane. So it was just challenging thing to face that challenges that is being faced from when we just work on a real-time projects. There will be just unstructured data, structured data, everything will be coming at once. So we need to just process, we need to find which to first, which to process first and which to process second. So the ranking must be done. So there was many challenges that I faced when I just worked on this PyBada, which is a Python project, like open source library. It is called as PyBada, which is a aircraft performance model. So there were like I have worked on that complete model where it could predict the trajectory, and many automations were done in that project. So I hope you enjoyed this session. Thank you for your patience. So the both winners can just contact me through my email. Like the Bonnie Chakrabarti and Sailendra Singh can just contact me through this email ID here. And I'll show you a website where you need to sign up. So just 1 second. So let me show you the website, fsts.poststep-solutions. I'll be posting this into the comment section. 1 second. So here you just need to sign up, and we'll be activating the course for you as we promised, like since you were the winners. And for the other peoples, we are just giving out a coupon code for the community people. Like you can buy any of this course. Like here you see like many courses are priced like around 2,000 or 3,000 something. So you can buy this course at 90% offer by using the code like FSTS90. I'll also be posting that code here. So 1 second, FSTS90. Yeah. So this is the coupon code which you can buy the courses for 90% offer. And also I'll be writing my mail ID. Yeah. So this is my mail ID. You can contact me through mail, and I'll also be sharing my WhatsApp number. So yeah, this is my WhatsApp number. So if you have any queries, just let me know in the chat box.
Participants, can you, if you have any queries, you can post your queries on the chat box. Regarding this session, if you have any queries, you can post your queries in chat box. Okay, Mr. Sabarish Kumar.
Yes, ma'am.
Okay, thank you for your excellent presentation on route to big data analytics.
So there is a question like Hadoop ++ configuration, it will be covered in the upcoming sessions. I saw that lesson plan. So hope you will get benefited in the upcoming sessions. So you may also Google about it. Okay.
Okay, thank you, Sabarish Kumaran. Thank you for your wonderful session. Participants, now you can go for lunch. After half an hour, you can join the session. You can use the same ID and password. The next session, session 3, will be start at 1:30 sharply. You can join before 10 minutes. Okay, thank you all. the PPT will be shared in the WhatsApp. At the end of the day 1 and day 2, you can get your PPTs in WhatsApp. Okay, thank you.